start again. It's a redskin.
Hey everyone, welcome to the first lecture of the new course where we are going to master one of the most popular programming language in the world, that is Python. So this is going to be a full course for beginners. We will start Python programming from basic level. So if you don't have any programming knowledge, then also you can take this course to start your programming journey with Python. So Python is one of the easy programming language to get started with programming. So let's move ahead with the agenda of today's lecture. So we are going to start this lecture by introducing you to Python. Then we will spend some time to understand the features that are provided by Python. And then we will see the application of Python. And at the end of this video, we will install the Python software. Now coming to the first topic of this video, what is Python? Python is fastest growing popular programming language in the world. Python is a high-level interpreted object-oriented computer programming language. Its high-level built-in data structure combined with its dynamic typing and dynamic binding makes it very attractive for rapid application development. If you don't know what does it mean by dynamic typing or interpreted language, don't worry, we will cover all these things in our upcoming lectures. Python was created by Guido van Rossum in 1989 and further developed by Python Software Foundation. In Python, instead of curly braces, the indentation is used to describe a block of code, which makes it structured. Now coming to the features of Python. Simple syntax of Python makes it beginner-friendly programming language. Now here note that this program is written in C programming language to print hello world. So if I want to print hello world on console, we need to write this many lines. So if I execute this code, so here note that it is showing hello world. Similarly, if we write hello world in Java, then we need to write this many things. And now if I run this code, so it is showing our output, that is hello world. But if you are using Python, then we need to just write print, and within parentheses we need to pass our message, that is hello world. So like this. And even we don't need to use semicolon to terminate our program. Now if I press enter, so it is showing our output. So coming to the next feature, Python is dynamically typed language. So let's see what does it mean by dynamically typed language. So this is the C programming language, and C programming language is not a dynamically typed language. So if I want to store an integer variable like a equals to 10, here I want to store 10 within this variable a. So 10 is an integer variable. So we need to write here int like this. So we need to first specify the data type. Then we can store the value in a variable like a equals to 10. So now if I want to print the value of a like %d, and then we need to write here a. Now let me execute this code. So here note that it is showing our answer, that is 10. That is value of a is 10. But if you are using Python programming language, then we need not to explicitly specify the type of that variable. Like we need not to write int a equals to 10, because Python is a dynamically typed language and the type of the variable will be decided at the runtime. So here we need not to write the int. So we can just write here a equals to 10, and then we can easily print the value of a, that is like this. So this is showing our answer, that is 10. So the next feature of Python is its library. Python provides us a large number of inbuilt library support that can be imported at any point of time, and it can be used in our program, which makes our program easy, and also we need not to write the code all by ourselves. So the next feature is object-oriented programming approach. Python supports multiple programming paradigms, and it also supports object-oriented programming approaches. That basically means Python supports the concept like class, object, inheritance, abstraction, polymorphism, etc. The next one is high-level language. Being a high-level language, we need not to worry about the low-level activities like memory management, coding architecture while writing the code. So the next one is Python is highly portable. If you write a Python code on Windows machine, then we can implement the same code for Linux machine also without changing the code. So this is basically wrap up this topic and move ahead and understand the application of Python. The application of Python is not limited within a specific field. Python is used for web development, data analysis, computer networking, and many more. It is a multi-purpose programming language which makes us possible to achieve all these things in less amount of code. So now we are going to download the Python software on Windows system. To download Python software, open your browser and write python.org and then go to downloads, and here download the latest version based on your system. So for Windows, so I'm downloading this, and after completion of the download, then open it and check on add Python path and then install now. So after installation, search for Python ideally on Windows search bar Python and then ideally, so and open this. So actually this is the Python shell, and in this shell we can execute single line statements like a print statement like this, hello, or we can perform any arithmetic operation like 1 plus 4 so that it is showing 5 and so on. But if you want to create a .py Python file, then we need to click here file and then new file and then save it like file, then save as, and then select the folder and then name here like example.py like this with .py extension and then save it. And now you can write your Python code here, like for example here I'm writing a for loop like for I in range of 10 and then print I like this. So if I run this code, so it is showing from 0 to 9. So don't worry, we will learn about this for loop and all those things. To run a program, you can run it from here like run and then run module, or otherwise you can press F5 from your keyboard like this. So now in this session we are going to explore the internal execution of a Python program. But before going to this topic, we need to understand various related terms like source code, machine code, byte code, compiler, virtual machine and interpreter. Then we can be finally able to understand the internal execution of a Python code. So our first term is source code. It is the programming statements written and understandable by the programmer. For example, if you write a program to add two integer number in any programming language, then the statements written by you is nothing but the source code. Next is machine code. Our computers are able to understand only sequence of zeros and ones. It cannot able to figure out the source code that is written by the programmer. So we need to somehow convert the source code into the sequence of zeros and ones. And this converted code is nothing but the machine code, which is understandable by the machine. Now coming to the byte code, it is neither the source code nor the machine code. We can say it as the intermediate code. Now at this moment I think you have understood the meaning of source code and machine code. And if you don't have a clear idea about the byte code, for now just note that byte code is an intermediate code between the source code and machine code. We will discuss about it in the upcoming slide. As I have mentioned that we need to translate the source code into machine code, and usually this is done by a compiler or by an interpreter. First of all, let's understand about the working of a compiler. In case of a compiler-based language like C or C++, after writing the source code, it will get compiled by the compiler and it will create a machine code. Now, if this compiler is installed on machine 1, then this machine code is executable only on machine 1. It cannot be executed on different machine like machine 2 or machine 3. This is basically makes the compiler-based languages platform dependent. For better understanding, look at the animation. For example, you have written a program to print hi using C programming language, which is a compiler based programming language. Now the compiler is going to take the source code and it will generate the machine code, which is understandable by the target machine only. Now this machine code will get executed by the processor and it will print the result, that is hello world. So now we can conclude that after writing a program by using a platform dependent programming language or compiler based programming language, the compiler will take the source code and based on that machine, based on the target machine, it will create a executable file. For example, if you are using a Windows compiler, then it will create a example.exe file, and this exe file will only executable on this particular system. Or if you are using a Linux compiler, then it will create a example.out file, and this file is only executable on this Linux machine. Similarly, in case of Mac OS compiler, it will create a example.out file which is executable on that particular machine. So it makes the compiler based language platform dependent. Now the question arises, why we need an interpreter if we already have a compiler? The real need of interpreter comes where compiler fails to satisfy some software development needs. We will understand this question by introducing you to the problem with compiler, and side by side we will also understand how interpreter deals with that problems. So first problem statement is, compiler compiles the entire program at a time. The problem occurs with this feature of compiler when the source code is large in size. Then it might take hours to compile the source code, as compiler first compile the whole program and then execute them, which will significantly increase the compilation duration. Here interpreters comes handy because interpreters are designed to translate single instructions at a time and execute them immediately. Now we will understand this point by an analogy. So here we have some balls and the task is to place all the balls from point A to point B within 6 seconds. We will do this in two different approaches. In the first approach, we will take one ball at a time and we will place it at point B, like this. So here note that within 6 seconds, by this approach we have successfully placed 4 balls at point B. And in the next approach, we will first collect all the balls and then we will place these balls together at point B. But note that in this approach, we haven't successfully placed any single ball at point B because we have so many balls. If we take the second approach, then we will not be able to place any ball at point B. It will spend a lots of time for collecting the balls. Now coming to the main topic, these balls are nothing but each line of source code, and interpreter analyze each line and execute it immediately, which is the first approach in our analogy. On the other hand, compiler analyze all the source code at a time, so it creates a problem when the source code is large in size. I want to mention something at this point. Don't think that compiled based languages are slower than the interpreted language from the above analogy, because in reality compiler based languages are faster than the interpreted languages. Because in case of interpreted language, it will create an intermediate code before creating the machine code, that is the zeros and ones. Here actually we have a source code which is large in size. In this scenario, compiler fails to satisfy the software development need. Coming to the next point, in case of compiler based language, it is harder to debug as compiler compiles all the source code at a time. So we get to know about all the errors together, which makes it harder to debug. But in case of interpreted language, it will take one line of code, so it will raise an error after the compilation of inaccurate line, which makes it easy to debug. The next problem is compiler based programming languages are not portable. Compiler will translate the source code into the machine code, and this machine code is only for the target machine. This machine code will not be executed on different systems. For example, if a program executes on a Windows system, it will not execute on the Linux or any other platform, so it is not portable. But in case of interpreter, it creates a byte code or the intermediate code, which makes it portable. We will see how it makes the programming languages portable in our upcoming lecture. So our next topic is Python virtual machine. It is the part of our Python software which takes the byte code and translates it into machine code. For example, we have seen that after compilation, compiler gives us the executable code or the zeros and ones, which is nothing but the machine code. But what if it doesn't give the machine code, rather it gives us the another type of code, which is the byte code, like this. So if I pass this bytecode to our target machine, then it will not be able to understand this bytecode. So here comes the Python virtual machine, which will take the bytecode and it will generate the machine code. And now this machine code can be executed on this system. Now let's understand the working of an interpreter. An alternative to a compiler is a program called an interpreter. Rather than converting the source code directly into machine code, it first converts the source code into an intermediate code or the bytecode. And then this code is converted into machine code by the interpreter for the target machine. It reads the source code line by line and translates it into machine code. For better understanding, follow the animation. For example, you have written a program to print hello world by using Python programming language, which is an interpreted language. So first of all, the source code will be compiled by the compiler and it will generate the bytecode or the intermediate code. And then this intermediate code will be executed by the virtual machine and then it will generate the machine code. And this machine code will be executed by the target machine and then it will print the output, that is hello world, like this. So we have understood the working of compiler and interpreter. Now we will compare the working of compiler and interpreter, and also we will learn how this interpreter makes the programming language platform independent. So let me briefly discuss about the working flow of the compiler. After compilation, compiler generates the machine code for the target machine. But the notable point is, if the compiler is installed on machine 1, then the generated machine code can only be executed on machine 1. It cannot be executed on any other machine. Now in case of interpreter also, the machine code which is generated by the virtual machine is also executable on the target machine only. It means if the interpreter is installed on machine 1, then this machine code will execute on machine 1 only. It will not execute on machine 2 or machine 3. So we can conclude that the virtual machine system dependent and it will create the system dependent machine code. Then where is the difference between the compiler and the interpreter? The difference can be noticed in the post-compilation code. In case of compiler, it will generate the system-dependent executable code. But in case of interpreter, it will create the bytecode, which is not executable by the machine directly. But the point is, it is not machine-dependent. The bytecode is machine-independent. It means if we have three different systems, then the bytecode created for the same source code on three different machines is same. This makes the programming language platform independent. After creation of the bytecode, it can be executed on any machine because now virtual machine is responsible to translate it into machine code for the target machine. Now you may ask why there exists an intermediate compilation stage in an interpreter. A strictly interpreted language is slow because an interpreter spends a lot of time for analyzing strings of characters to figure out what they mean. A compiler translates the source code, some kind of data structure which is represent the source code in more convenient way. Rather than stepping through the string of characters, it steps through a data structure which is much faster to operate on. Now we can able to conclude some points about interpreter, like bytecode is intermediate code, it is understandable by the virtual machine, and bytecode makes the programming language platform independent. After creation of bytecode, we can run this bytecode on any machine. Now coming to the final topic, which is the internal execution of the Python code. So Python is usually called an interpreted language, although compilation is one of the steps. The source code with .py extension will be first compiled and it will create a .poc file which is called bytecode. Now this bytecode is further interpreted by Python virtual machine, which is a part of Python system, and it will translate the bytecode into the machine code, and then the CPU will execute the code. As a result, we get our output. Now we will finish this topic by answering a question. That is Python machine independent or not? The answer is Python is machine independent, but it is PVM dependent. We can run a Python bytecode on any machine, but Python virtual machine should be installed on that particular machine. In this session, I am going to discuss about the notion of identifier and variable in Python. Let's move ahead with our first topic, that is identifier. Let's assume a scenario where your friend is in a crowd and you need to call him. So how will you call your friend? Obviously by the name. Similarly, in a Python program, you may define multiple variables, functions or classes. So to uniquely identify them, we must give them a name. and this name is nothing but an identifier. By the definition, an identifier is a name given to any entities like class, function, variable, etc., which is mainly used for identification purposes. There are some rules to define a name in Python. So I have listed all the rules that we need to follow to name an identifier in Python. So the first one is, it can be a combination of uppercase alphabets or lowercase alphabets or the digits and underscore sign. For example, we can declare a variable name like age equals to 28, or we can use age equals to 28, or we can also use the combination of alphabets and underscore like my underscore age equals to 28. Now we can also use an alphanumeric name like Python 3 equals to 10. This is also valid, but according to the second point, a name cannot start with a digit. Like this is a valid declaration, but if you try to declare it like this way, 3 Python equals to 10, it will raise an error because name cannot start with a digit. And then the special symbols are not allowed. We can use only the underscore sign, but we can't use anything apart from this. Like my @age equals to 28, it will raise an error. Okay. So our fourth point is keywords cannot be used as an identifiers. So what is keywords? Keywords are the reserved word in Python which has a predefined meaning. So we cannot use a keyword as an identifier name. For example, while is a keyword. So if I try to use it as a variable name, then it will raise an error like while equals to 10, and now if I press enter, it will show an error. Now you will find all the keywords present in Python by writing one single statement, that is help, and then within parentheses we need to pass keywords. So these are the keywords which are present in Python 3. Here I want to mention 2 points about identifiers. Identifiers can be of any length. You can declare a very long name of an entity, but the idea is always use a compact and meaningful name for the particular entity. Like if you want to store the age of a person, then you can simply write a equals to 28. But it is not a meaningful name. But instead of a, if you write age equals to 28, then it reflects the original meaning of that entity. So my second point is Python is a case sensitive language. I have told you that for is a keyword, so we cannot use it as an identifier name. But if we change this first alphabet, that is F, from lowercase to uppercase, then we can happily use it as an identifier name, because for and for are different in Python language. Similarly, name and name are two different identifiers. Coming to the next topic, that is variable. A variable can be thought of as a container. Generally in our home, we use different containers to store grocery items. Similarly in programming also, we need a container to store values. It may be an integer value or a string or something else. So variables are nothing but the reserved space in memory which is used to store different values. To declare a variable, we need to give a name so that we can uniquely identify it whenever it is required. So here I am declaring a variable with name val and then assign the value. So I have assigned a value 19, which is an integer value. Now val is the variable name and 19 is the value that is assigned to it. Not only integer value in a variable, we can also store float, string, etc. We will see different data types in details in our upcoming lectures. But before ending this session, I want to mention two functions that are print and input. These two functions are called input-output functions. We will see about these two functions in a great detail when we will be dealing with the input-output statements in our upcoming video. But for now, just note that print is basically used to print an output. For example, if I write print and then within parentheses, if I pass val, then it will print the value of val, that is 19. When we need to take inputs from a user, then we have to use input function. For example, if I try to take the age from a user, then we need to write input and within parentheses we can pass the message like enter your age, like this. Now after this, user is going to enter the age. But the question is where it will go, because we need a container to store this age. So we need to declare a variable like this. Age equals to, then we can write this statement. In this session, I'm going to discuss about the internal representation of a variable in Python and also the notion of constant in Python. In Python, variables are quite different from variables in C or C++. Actually, Python doesn't have any variable. Rather, we can say that it has a tag or names. First of all, let's understand the working of variable in C. Then we will be able to differentiate the Python variable from it. In case of C or C++, we need to first define the variable type, based on which some space in memory will be reserved. And within that space, the value, that is 10, will be stored. And the variable name A will be mapped with that memory location. Now, if you try to change the value, that is from A is equal to 10 to A is equal to 20, then the value that is stored in memory location 2016 will also be changed from 10 to 20. But if you try to declare the new variable with same value, that is B is equal to 10, then again a new memory location will be reserved for that, and 10 will be stored in that location, and also B will be mapped with that memory location. Now let me demonstrate it practically. So this is a C program. For now, just ignore this part and just focus on these lines. In the first line, I have declared an integer variable, that is A is equal to 10, and then this line will print the value of A, and this line is responsible for printing the memory location of A, and then I have changed the value of A from 10 to 20, and then again I am trying to print the updated value of A and the memory location of A. Now let me run this code. Now note that initially the value of A is 10 and the memory location is 65FE1C. After changing the value has got updated, that is 20, from 10 to 20, but the memory location still remains same. Now let's see what happens if we declare a new variable with same value, that is B equals to, let me define a new variable, that is B equals to 10, and then if I print the value of B and the memory and also the memory location of B. Now note that the memory location of A is 65FE1C, but the memory location of B is 65FE18, that is different. So in this case, a new memory location is created for the new variable. Now we can conclude that in C or C++, if we change the value of existing variable, then it will not going to create a new memory location. But if we create a completely new variable, then it will assign a new memory address for that variable. In case of Python, the picture is quite different. Actually, Python doesn't have any variables. It has names, that is a reference to an object. After assigning the name A to the object, CPython interpreter, that is the standard Python interpreter written in C, will create a Pyobject. Now you may ask, what is a Pyobject? Actually, the CPython interpreter translates all the objects in Pyobject at runtime, which has basically three fields, that are type, value, and reference count. After declaring the variable, the type field is going to set integer, the value field 10, and the reference count will set to 1. And the name A is going to point the Pyobject in memory. Now if I try to declare a new variable with same value, then Python will not going to create a new Pyobject. Rather, the new name will also point the same Pyobject, as the value is same in both variables. Only the reference count will get increased by 1. Now if I try to change the value of x, then Python is going to create a whole new object. Unlike C or C++, it will not going to change within the same memory location. It will create a new Pyobject because of immutable nature. We will see this mutable and immutable topic in our upcoming lecture. The tag A will now point to the new Pyobject, and the reference count of the previous Pyobject will become 0, and it will be deleted by the garbage collector. Here I have declared an integer variable, that is x is equal to 10, and then this line will print the memory location of x. This id is an inbuilt function that is used to print the memory location, and then I have changed this value of x from 10 to 12, and then again I am trying to print the memory location. Now if I run this code, now note that the memory locations are different. Okay, but we have seen that in case of C language, if we try to change the value, it will not going to create a new memory location. Rather, it will change the value of existing location. Here I have created multiple variables with same value. In this case, Python is not going to create different Pyobjects for each of the variables. Rather, these tags A, B, C, and D are going to point the same Pyobject in memory, and the reference count field of that Pyobject will be 4. Now let me run this program. Note that the memory addresses are same for each of the variables. So this is all for this video. In our next video, we will learn about the notion of constant in Python. In this session, I am going to discuss about the constant in Python. As the name suggests, it is a container that stores data whose value cannot change during program execution. But technically, Python doesn't have the concept of constant. So, to understand it in a better way, we will first learn the feature of constant in C. Because in C programming, we have the notion of constant. And then we will see how we can use the constant in Python. So here I have declared an integer variable, that is x is equals to 10. And then this line will print the value of x, that is 10. And here I have declared a constant, that is pi equals to 3.14. This const keyword is basically used to define a constant in C programming language. And in this line I have changed the value of x from 10 to 30. And then again I am trying to print the value of x. Now let me run this code. Now note that the initial value of x is 10 and the updated value of x is 30 because x is a variable. So we can change the value of x in the program execution. Now if I try to change the value of a constant, that is pi is equals to 4. If I change the value of pi from 3.14 to 4, then it will raise an error. That is assignment of read-only variable pi, because pi is a read-only variable. We cannot change after declaring a constant. So if someone change the value of a constant unintentionally in C programming language, then it will raise an error. But in Python, we don't have any keyword to define a constant. Or we can say that Python doesn't have the notion of constant. For example, if we declare a variable like this pi equals to 3.14, then there is no assurance that it will remain constant throughout the program. Because if the value of pi is changed by any mistake, then the value of pi will get updated. For example, if I print the value of pi, now it is showing 3.14. But by any mistake, if the value of pi is got updated like this, pi equals to 3.14 to pi equals to 4, then now it will not going to raise an error because this is a normal variable and a value of a variable can be changed at any point of time. Now if I print the value of pi, so now it is showing the updated value, that is 4. So what is the solution, or how we can use a constant in Python? Actually, we have two solutions. We will see each of them practically. First one is we can create a separate file for constant values. Then import it in our main program file and use the constant values by the file name like constant.py. Let me do it practically. First of all, we need to create a Python file where we will declare a constant values. To create a new file, click on file and then go to new file and save it. Select the folder and then name it. You can give any name. Here I am giving constant.py, and here I am declaring two constant like pi equals to 3.14 and then g equals to 9.8, and then save it. And now create the main file. To create the main file, go to file and then new file and save it. Select the folder and name it. You can give any name. I am giving it main.py. First of all, we need to import the constant file. So import is a statement that is used to import another Python file in our program. We will learn about it in our upcoming lectures. But for now, just remember that import is used to import another Python file in our program. So now we can use the constant variables like this. If we try to print the value of pi, which is written in constant.py, so we can access this by the file name, that is constant.py. Run the program. Now it is showing 3.14. So now if I change the value of pi from 3.14 to any other value, then it will not going to affect the value of pi which is written in constant.py. For example, if I change the value of pi from 3.14 to 4 in this program, then it will not affect our constant.py. Like if I run this program, now note that it is still showing 3.14. So someone if mistakenly changed the value of pi from 3.14 to something else in this program, then it is not going to affect our actual constant pi. But it doesn't mean that constant.py has all the features that we have seen in case of constant in C programming language. For example, we have seen that in case of C programming language, after declaration, the value of the constant cannot be changed. But in this case, the value of pi that is written in constant.py file can be changed in our main program. Like if we write constant.py equals to 4, and now if I print the value of constant.py, let me run this program. Now note that the value of pi has got updated. So our next approach of declaring a constant in Python is by using pconst library. Again, I want to mention that we will learn about this library, module, all those things in our upcoming videos. For now, just note that pconst is a Python library. Now to use it, we need to first install it. To install it, open cmd and now type pip install pconst. So now it has installed. So now import it like this way, from pconst import const. Now to declare a constant by using this library, we need to write const and then define the name of the constant, that is pi equals to 3.14. Now print this. Now let me run this program. Now note that it is showing 3.14. Now if I change the value of const.py from 3.14 to 4, now it is going to raise an error like constant in C programming language. Now let me run this program. Now note that constant value of pi is not editable. So we have completed the concept of variable, and we have seen that variables can be thought of as a container where we can store some data. And in this session we will be looking at different data types. Data type is the categorization of data items. It represents the kind of value that tells us what kind of operation can be performed on that data, or what will be the answer for a particular operation. For example, if we use addition operation on two integer data, that is 5 and 7, then we will get 12 as the output. But if we perform the same operation on two string data, that is coding and tactics, then it will append the second string to the end of the first string, which is also known as string concatenation. We will learn about it in our next video. So in Python we have total 14 data types, where we have 5 primitive data types and 9 collection data types. In this session we will look at the 4 data types, that are integer, float, complex and boolean, and these 4 data types are also called numeric data types because they represent the numeric values. So coming to the integer data, it contains positive or negative whole numbers without any decimal point. In Python there is no limit to how long an integer value can be. Like you can declare a small number like a equals to 20, or you can also declare a long integer value like this. Python will not going to interrupt you. Now type is an inbuilt function which is used to print the type of an object. Like if we pass a within this parenthesis, then it will going to print int, because 20 is an integer number. In mathematics, we have different number systems that are decimal, binary, octal, and hexadecimals. Decimal number system has base 10, which means decimal number system has 10 unique digits that are from 0 to 9. And generally, we use decimal number system in our daily calculation. And this number system is always used by Python to output an integer number. Like if you print 5 plus 5, then it is going to print 10, which is an example of decimal number system. But in Python, we can also play with different number system like binary, octal, and hexadecimal. So coming to the binary number system, it has base 2, which means it has only 2 unique digits that are 0 and 1. To store a binary number in a variable, we need to add 0b before writing the binary form of any number. Generally, Python is a case-sensitive language, but in this case, you can write this b either in uppercase or in lowercase. It will not raise an error. Here I am not going to discuss about the conversion of a number from one system to another system. In this course, we are going to use only decimal number system. So if you don't have any knowledge of this number system, then also your programming journey will not be hampered for this. For now, just remember that 1100 is the binary representation of 12 and 0010 is the binary representation of 2. And if we add them, we will get 14 as output, whose binary representation is 1110. Now this binary representation are in 4-bit format. Now let me declare two binary numbers. To declare a binary number, we need to write first 0 and then b, and then we can write the binary representation, that is 1100. And again b equals to 0b and 0010. Now here I am going to declare another variable c, where I am going to store the addition of a and b, that is a plus b, and this line will print the addition. So as I have told you that Python always going to give an integer output in decimal number system only. Here I have declared these numbers in binary format, but it's showing the addition in decimal format. So now the question is there any way to represent this decimal number in binary format or not? Now to print this addition in binary format, we need to use another inbuilt function, that is bin. So we need to write bin, and then within parentheses we can pass the number whose binary representation we want to print. In our case, we need to pass c within this parenthesis. And now we are going to store this binary representation in another variable, that is d. Now if we print d, it is showing the binary representation, that is 1110, which is the binary representation of 14. Here the notable point is, if I print the type of c, now it will be showing integer value, that is class int. Now I try to print the type of d, then it will be showing string format, because bin is a function which takes the integer input and then it will print the binary representation. But this binary representation is not an integer value. It converts the integer number into the string of binary sequence. And within this parenthesis, we can pass any form, like we can pass a octal number or a hexadecimal number also. And we will get the binary form as the output. But this binary form is not an integer number. It is a string of binary sequence. Similarly, we have also octal number system, and it has base 8, which means it has 8 unique digits that are from 0 to 7. Now to store an octal number, we need to add 0 before writing the octal number, and here also you can write this O either in lowercase or in uppercase. To understand this number system, remember that 62 is the octal representation of 50 and 144 is the octal representation of 100. So let me define an octal number, that is a equals to 0 and then 62, which means 50. Now here I'm going to declare another variable, that is b, and where I'm going to store the addition of a with a. And this line will print the value of b. Now again, note that we have actually added 50 with 50, that's why it is showing 100. And it is in decimal form. If we want to print this in octal form, then we need to use another inbuilt function, that is oct. So we need to write oct, and within parentheses we need to pass the value whose octal form we want to print. So in our case we need to pass b. And let me store it in another variable, that is c equals to this, and then if I print the value of c, now it is showing in octal form because 144 is the octal representation of 100. This oct function is similar to bin function because here also we get output which is actually a string value, because if I print the type of phi, so it will be showing str type, that is a string type. So our last number system is hexadecimal number system, and it has base 16, which means it has 16 unit digits that are from 0 to 9 and A to F. Now to represent a hexadecimal number system or to declare a hexadecimal number system, we need to write first 0 and then x, and then we can write the hexadecimal form. To understand this, note that 5e is the hexadecimal representation of 94 and 32 is the hexadecimal representation of 50, which means 94 and 50 are in decimal form. Now let me declare two hexadecimal number, that is a equals to 0x and then 5e, and again b equals to 0x and 32. Now let me declare another variable c where I am going to store the addition of a and b, and this line will print the value of c. Actually we have added 94 with 50, that's why it is showing 144, but 144 is the decimal form. To print this answer in hexadecimal form, we need to use the inbuilt function, that is hex, and within parentheses we need to pass c. So now it is showing the hexadecimal form of 144 because 90 is the hexadecimal form of 144. 144 is the decimal form. So we have done with integer data type. Now moving forward to our next data type, that is float data type. It is a real number with floating point representation. It is specified by a decimal point. For example, a equals to 5.5 is an example of floating point value. We can also check the type of a by using the inbuilt function type. So we need to pass a within parentheses, and now it is showing the type is float. Now we can also represent a floating point number in scientific way. What I mean by scientific representation is, for example, we have a floating point number like this. Now if I print a, so now it is showing like this, 2.1 e to the power minus 19. This is nothing but the scientific representation. We can also represent this number, or we can also store this number this way in Python. So what we need to do is a equals to 2.1 e to the power minus 19. So it is also valid. Now we can only use decimal number system to represent a floating point value, otherwise it will raise an error. Like if I try to represent a floating point value in binary form, then it will raise an error like equals to 0b1100.0b1100. It will raise an error like this. So our next data type is complex. It is basically used in mathematical calculation, where the concept of complex number is involved. It has two parts, one is real and another one is imaginary, and this imaginary part is declared with j, like a equals to 5 plus 6j, and here also this j can be written in uppercase or in lowercase. It will not raise an error. So here 5 is real part and 6 is imaginary part. Now we can also declare a complex number like this, b equals to 7j. Here I have not declared any real part, so it means the real part is 0, or it is similar to 0 plus 7j. Okay. Now if I print the type of A, so it will be showing complex type. Similarly for B also, it is complex. And we can also use arithmetic operations on this data like addition, subtraction, multiplication, etc. For example, C equals to A plus B. Now if I print the value of C, so it is 5 plus 13j. One of the notable point about this complex data type is this real part and this imaginary part can also hold a float value. Python will not going to raise an error. Like if we declare a variable like 5.5 plus 6.6j, then Python will not going to raise an error. It is also a valid declaration. And another point is C equals to, if I declare a complex variable like 0b1100, which is the binary representation of 12, and plus 4.5j, then also it is a valid declaration, because in real part we can store the value in any form like binary, octal, hexadecimal or decimal. Python will not going to raise an error. But in case of imaginary part, we can only store the value in decimal format only. Otherwise it will raise an error. Like d equals to 0b1100 plus 0b1100j. Now it is going to raise an error because imaginary part can hold only decimal form. Okay. Now coming to the last numeric data type, that is Boolean. In this we have only two inbuilt values, that are true and false. It is basically used in logical operations, and also it is used to create conditions and control how the program behaves when certain things happens. For example, if you try to know whether 5 is less than 7 or not by writing a equals to 5 less than 7. Now Python will going to give the value in Boolean form. If it is true, then it will give true, otherwise it will give false. And the value will get stored in A. Now if I print A, so it is showing true. And this line will print the type of A, that is Boolean or bool. So this is all about numeric data type. Now we will learn different inbuilt functions that can be operated on numeric data types. So our first function is apps. Apps basically takes a numeric data or a negative numeric data like -45, and it will print the absolute value or the positive value of that number. So in our case it is -45, so it will print +45 or 45. We can also pass negative floating point value like 4.5, so it will print positive 4.5. Within apps function we can also pass a complex number like 3 plus 4j. So in this case it will going to print the magnitude of that complex number. So our question is how to calculate the magnitude of a complex number. For example, we have a complex number that is a equals to 3 plus 4j. Now we need to calculate the square of these numbers, that is 3, the square of 3 that is 9, and the square of 4 that is 16. And then we need to add them. And again we need to find the square root of 25 or the addition, that is 5. So 5 is the magnitude of A. Now if I print the answer, now it is showing 5.0. But note that it is showing a float value, that is 5.0. Because if we print the type, that is type of apps of 3 plus 4j, so it is showing float value. So if we pass a complex number within apps, it is going to print the magnitude of that complex number, but it will return the answer in float data type. We have already covered all the numeric data types in a great detail. In this session, we are going to discover another data type, that is string. String is a fundamental or primitive data type that cannot be broken down further into simple data type. It can be thought of as a collection of alphabets, digits, or special characters. To declare a string, we need to use either single quote or double quote. For example, a equals to Python is a string. You can check the type of a by using type function. So it is string. If I store 550 within b like this way, then the type of b will be integer type. You can check the type of b, so it is integer. But if I enclose 550 within a single quote or double quote, like c equals to within double quote 550, if I declare 550, then the type of c will be integer. So here the point is, the conclusion is, anything enclosed by either single quote or double quote is a string. For example, p equals to within double quote, if I write, so this value is also a string. Check the type of p, so it is showing string type. Now let's see how does a string value store in memory. To store a string data, Python basically follow the UTF-8 encoding scheme. Before going to understand this UTF-8 encoding scheme, we need to first understand the term Unicode. So what is Unicode? The Unicode standard is the universal character representation standard for text in computer processing. Unicode provides a consistent way of encoding multilingual plain text, in which each letter, digit or symbol is assigned with a unique numeric value that applies across different platforms and programs. As you can see that lowercase a is assigned with the numeric decimal value 97. Similarly, lowercase b is assigned with 98. So in this UTF-8 encoding scheme, it first converts each character of the string to its corresponding Unicode. And then the Unicode of these each characters are converted into 8-bit binary representation. And this binary representation is going to store in memory. For example, here we have a string value that is p equals to hello. In UTF-8 encoding scheme, the Unicode of each character is going to convert it in 8-bit binary representation. And this whole stream of bits will be stored in memory. This is how a string is stored in memory. Now we are going to learn about the notion of slicing in Python. But before that, we need to understand about indexing. I have told you that string is a collection of characters, so we can represent a string like this way. Here we have a string that is p equals to address, and we can index each of these characters from 0, like h has index 0 and e has index 1 and so on. This indexing scheme is known as positive indexing because we have also negative indexing, where we take last character of the string and consider the index of it as -1, then -2 and so on. So positive indexing of first character is 0 and positive index of the last character is n-1, where n is the length of string. In case of negative indexing, the index of first character is -n, where n is the length of the string, and the negative index of the last character is -1. By using this indexing concept, we can print any character from a string. Like we have a string d equals to coding, and we have seen that the first character has the index 0 or the positive index 0, and the second character has the positive index 1. So if I want to print this character, that is O, then we need to write the string name d, and then within square bracket we need to pass the index of that character. In our case it is 1. So if I pass 1 and then if I press enter, now it is showing the character, that is O. Similarly, we can also use the negative indexing concept. As we know that the last character has index -1 and then the second last character has -2. So if I want to print n by using negative indexing concept, then we need to write d, and within square bracket we need to pass -2. Now it is showing the character, that is n. But assume that we need to print multiple characters from a string. For example, we want to print these 4 characters. Okay, then what we need to do, the first approach is we can print like this way: d of 0 1 2, okay, from 2, then again d of 3, d of 4, and d of 5. So we can print like this way, but it is not the efficient one. So here the concept of slicing comes into picture. Assume that we have a string k equals to Python programming, and from this we want to print Python, that is we want to print from index 0 to index 5. To print it, we are going to use the concept of slicing. To do that, we need to first write the name of the string, and then within square bracket first write the beginning index, that is 0 in our case, and then we need to write the end index plus 1. In our case the end index is 5, but we need to write 5 plus 1, that is 6, and we have to give colon between these numbers. Similarly, we can also extract the word programming from the string k. To do that, we need to write 6 as the beginning index, and then 16 plus 1 equal, that is 17, as the end index. Here I have declared the word Python programming. Now if I want to extract Python from this string, then we need to write a, and then within square bracket we need to pass first the starting index, that is 0, because I want to extract Python, so the starting index is 0. Then we need to give colon, and then the end index. So end index is 0 1 2 3 4 5. So here the end index is 5, so we need to pass here 5 plus 1, that is 6. Now if I press enter, so it is showing Python. Now we can also add another argument within square bracket, which is actually optional, but you can use it if it is required for your program. That is the step value. We can add it after the end index. By default the value is 1. That's why if we don't mention it, then it will start printing all the characters from one after another. But if we mention the value of it as 2, then it will start printing the string by skipping one character, and it will print the output something like this. So here we have the string Python programming, and I want to print the whole string by skipping one character. Like it will print p, then it will skip y, and then again it will print t, and so on. So to do that, we need to write the string name a, and then within square bracket we need to pass the starting index, that is 0, and then the end index, that is 16, but we need to pass 16 plus 1, that is 17, and then we need to pass the step value, that is 2. So this is our output. Now what if we don't write the starting index or the end index? Like I want to print the word Python from the string a. So I have mentioned it like this way: a within square bracket. So I have mentioned the end index, but I did not mention the starting index. Now in this case the starting index will be considered as 0. So it will start to print from index 0, and it will print the word Python. Similarly, if we don't mention the end index, then it is going to print up to the end of the string. Now before ending this session, let's conclude some points about slicing. That is, the syntax of slicing is we need to first write the starting index, then we need to write the end index plus 1, and then the step value. The default value of step is 1. If we don't mention the starting index, then it will start from index 0. Similarly, if we don't mention the last index, then it will consider the whole string. In our previous video, we have already discussed about the concept of slicing, but in this session we are going to understand something more about slicing. But before that, let's recap the slicing concept by a flow diagram. As you can see that we have string wxyz and we want to execute this line, that is E, and within square bracket we have 0 as the start index and 3 as the end index. And we have also declared the step value as 1. And our expected output is wxy. Now, the initial value of current index is the value of the start index. In our case it is 0. Then it is going to check whether the value of current index is greater than or equals to the value of the end index or not. So here the value of current index is less than the end index. So the character that is present at index 0 will go to the output side. Now we have mentioned the step value as 1. So 1 will be added with the current index and the current index will become 1, and again it will check the condition, and here also the value of current index is less than the end index. So the character which is present at index 1 will go to the output, that is x. Then again the step value, that is 1, will get added with the current index, and the new updated value of current index is 2, which is less than the end index, and it will also go to the output. Now at this time our current index will be 3, which is equal to the end index. So the character that is present at index 3, that is z, will not go to the output side, and the slicing will be terminated. So here we have a string Python programming, and if I want to extract or print the word Python from this string, then we need to write a, and within square bracket we need to pass the starting index first. In our case it is 0, so we need to pass 0, and then we need to give colon, and then we need to write the end index plus 1. So our end index is 0, 1, 2, 3, 4 and 5. So we need to pass 5 plus 1, that is 6. Now it will print Python. We can do all these things by using negative indexing concept also. But here I have divided this concept in 3 different cases. So first one is when the last character or the character having index value -1 is not involved. And the second one is when the last character is involved. And finally when the step value is a negative number. So coming to the first case, that is when the last character is not involved. For example, here we have a string Python programming. Now if I want to extract this Python word from this string, then the last character, that is G, is not involved. So to print it using negative slicing concept or by using negative indexing, then we need to write a, and then within square bracket we need to pass the beginning index. So our beginning index will be -17. This p is present at index -17. So we need to pass -17, and then we need to give colon, and then we need to pass the end index. So our end index will be -17, -16, 15, 14, 13 and 12. So our end index is -12. So our end index is -12, but we need to pass end index plus 1. So -12 plus 1, that is -11. So our second case is when the last character is involved. For example, from this string, if we want to print programming, then the last character, that is G, is involved. So to print it, we need to write a, and then within square bracket we need to pass the first index. So our first index is, or the starting index is p. Now p is present at -11. Okay, so we need to write -11, and then we need to give colon, and finally we need to write the end index. So our end index is at -1, but we need to print end index plus 1, that is -1 plus 1, that is 0. Now if you write 0, then it will not going to print anything like this. The reason behind it is simple. So here we are using negative indexing, and we have our end index as -1, and if we add 1 with it, then we will get 0. But we don't have any concept like -0. So if we write 0, then it will consider 0, which is the first index. Now we have started from the index value -11 or the index 6. But at the same time, we have mentioned 0 as the end index, which means the starting index is greater than the end index, which is not a valid declaration. Because we have seen in our flow diagram that each time the step value is added up with the starting index, and at the same time it will check whether it is greater than or equals to the end index or not. If the condition satisfied, then our slicing will get terminated. And here comes the problem, because if we declare like this way, then at the very first moment the termination condition, that is the starting index is greater than end index, will get satisfied and slicing will stop and it will not going to print anything. To avoid it, we need to write a, and then within square bracket we need to pass the starting index, that is -11 as it is, and then we need to give colon, and then instead of passing 0 we need to pass none. Then it will going to print our expected output, that is programming. Or otherwise you can simply skip this part like a, and then within square bracket you need to pass -11, then colon, and then you can just skip it. Then also it will print programming, because if you skip it, then it will by default it will take up to the end of the string. We can also give the negative step value, but in that case we need to change the syntax. We need to first write the end index and then start index -1, and it will print the string in reverse order. For example, if I want to print this programming in reverse order from this string, then we need to write a, and then within square bracket we need to first pass the end index, that is 17, and then we need to give colon, and then the start index -1. So in this case our start index is at 6, so we need to pass 6 -1, that is 5, and then we need to write the negative step value, that is -1, and if I press enter, so this is our expected output. In this session we are going to learn different methods that can be applied on string data. These methods are very useful while solving problems related to string using Python programming language. For example, here we have a string Python is fun. Now I have written some lines of code which is responsible for printing the number of occurrence of the alphabet n within this string. Now here n has occurred 2 times. So if I run this code, then it will print 2. So it is showing 2. We can do all these things by using inbuilt method in one line. So what do we need to do? We need to use the count method. To do that, first write the string name, that is a, and then use dot, and then write count, and within parentheses you need to pass the required alphabet, that is in our case it is n, and then it will return the number. So you can store it in another variable b, or you can directly print it. So here I am going to print it directly. So this is our answer. So our second method is capitalize. It will return a string where the first character is in uppercase and rest are in lowercase. For example, we have a string like this, Python. Now if I use capitalize method on this string, to do that we need to write the string name a, and then dot, and then write capitalize. Now note that we need not to write anything within this parenthesis. Now if I press enter, here the first letter is in uppercase and rest are in lowercase. Now don't think that the actual value of a has changed after application of this method, because the value of a still remains same. You can check it by using the print statement. Now note that the value of a still remains same. If you need to work with this value, then you need to store it in another variable like b equals to a dot capitalize, and now you can use this new string with this variable name. And this concept is also applicable for all the methods. So our next method is upper. For example, we have a string like p equals to programming. Now if I use this upper method on this string, then it will change all the characters in uppercase, like p dot upper, And here also we need not to pass anything within this parenthesis. So here all the alphabet are in uppercase. Similarly, we have another method called lower, which convert all the character in lowercase. For example, we have a string like a equals to Python. Now if I use lower on this string like a dot lower, so note that here all the characters are in lowercase. So our next method is swap case, which will return the string where all the uppercase are in lowercase and vice versa. For example, we have a string like this, and if we use swap case on this string like a dot swap case, now note that here p is in uppercase, but here p is in lowercase. Our next method is center. This method is basically used to align the string. If I print a string, then by default it is aligned at left side, that is like this way. But if you try to align it in the middle, then you can use this method. So you need to write the string name, that is a, and within parentheses you need to pass the length. Here I am passing 75, and now if I press enter, now it has aligned at the middle. You can change the length by changing this value. Note that this extra length is basically filled with blank spaces, but you can change it by any string value. To do that, we need to pass another parameter in this parenthesis. For example, a.center, and within parentheses first pass the length, that is 75, then pass the string. Here I am going to fill these blank spaces with 0, so here I need to pass 0. Now if I press enter, now note that these blank spaces are filled with 0. So our next method is find. If you want to find the index of a substring, or more precisely the starting index of a first occurrence of the substring, then you can use this method. For example, I have a string like b equals to programming. So here I want to find the index of the first occurrence of m. So we can use find method like b dot find, and within parentheses we need to pass the character, that is m. Now if I press enter, now note that the first occurrence of m has at index 6. So our next method is index. This method is exactly similar to find method. The only difference is whenever the specified string is not present in this string, then it will print -1. But index method raise an error if the substring is not present in the original string. Like we have a string like a equals to Python is fun. Now here we don't have the word programming. So if I use index method on this string like a.index, and then I want to find programming within this string, but we don't have the programming word in this string, so it will going to raise an error like this, substring not found. Our next method is ends with. This method returns whether a string ends with a specific character or not. Like we have a string a equals to Python is fun. Now if I want to know whether this string is ends with fun or not, then we need to write a dot ends with, and within parentheses we need to pass the word, that is fun. So here it is ends with fun, so it will print true like this. Similarly, we have another method that is starts with, which will return whether a string is start with a specific character or not. For example, in this string it start with Python. Now if I want to check whether this string is start with Python or not, then we need to write a, then dot starts with, and then within parentheses we need to pass Python in our case. So it is true. So our next method is length. It will return the length of the string or the number of characters present in the string. For example, here we have a string Python. Now if I want to check how many characters are there in this string, then we need to write length, and then within parentheses we need to pass the name of the string, that is A. So here we have 6 characters. Next is replace. If you want to replace a portion of a string with a new value, then you can use this method. For example, here I want to change this M into O. So we need to write b dot replace, and within parentheses we need to first pass the old value, that is M, and then we need to pass the new value, that is O. Now if I press enter, so it is showing the updated value. So our next method is title. It will return the updated string where the first alphabet of each words are in uppercase. So here I have a string Python programming. Now if I use title method like b.title, now note that this P and this P are in uppercase. So our next method is strip method. It will return the trimmed version of a string. For example, we have a string like this where we have some unwanted space in both the side of string. Then we can use this method like a.strip like this. So this is our output. Here you can also trim only the left side or the right side. To do that, you need to use lstrip to trim only the left side, and you can use rstrip to trim only the right side. For example, if I write a.lstrip, then it will trim only the left portion like this. So this is all for this video. In our next video, we will learn rest of the string methods. In this session, we are going to learn some string methods which will check a certain condition and based on which it will return either true or false. For example, here we have a method that is isUpper. It will return true if all the alphabets are in uppercase. For example, here we have a string that is equals to Python where all the alphabets are in uppercase. So if I apply this method on this string like a.isUpper, then it will print true. Similarly, here we have another string that is b equals to Python where only the first letter is in uppercase and the rest are in lowercase. So if I apply this method on this string b for a b.isUpper, so it will print false because here only the first letter is in uppercase. So our next method is isLower. It will return true if all the alphabets are in lowercase. For example, here we have a string c equals to Python. Now if I apply this method on this string c like c.isLower, then it will print true. But if I apply this method on this string where all the alphabets are in uppercase, then it will return false like a.isLower. So it is showing false. So our next method is isAllNum. It will return true if a string contains only alphabets and numeric numbers. For example, here we have a string a equals to Python 3 which contains only alphabets and digits. So if I apply this method on this string, then it will return true like a.isAllNum, then it will return true. But here we have a string that is b equals to Python @3. Here a special character is involved. So if I apply this method on this string, then it will return false like b.isAllNum. So it is showing false. So here we have another method that is isAlpha. It will return true if a string contains only alphabets like this. Here we have a string that is equals to Python which contains only alphabets. So if I apply this method on this string like a.isAlpha, then it will return true. Here we have another string that is b equals to Python 3 which contains a digit also. So if I apply this method on this string like b equals to isAlpha, then it will return false like this. Similarly, here we have another method that is isDigit. It will return true if a string contains only digits. That is, here we have a string that is equals to 550. If I apply this method on this string a.isDigit, it will return true. But here we have another string that is Python 3 b equals to Python 3 which contains alphabets also. So if I apply this method on this string, it will return false like b.isDigit. So our next method is isTitle. It will return true if the first alphabet of each character is in uppercase. For example, if I apply this method on A, then it will return true. like this. But if I apply this method on this string b, then it will return false, like b dot is title, so it is showing false. Now we have another method, that is split. This method split the string based on a specific character. For example, here we have a string a equals to Python programming is easy to learn. Now if I apply this method on this string a, then it is going to split the string based on these blank spaces. Because if we don't specify anything within this parenthesis, then it will take these blank spaces as the separator. So if I apply this method like a dot split, and within parentheses I'm not going to pass anything, so it will take the space as the separator. So this is our output. But if we have a string like this, where we have a string where each words are separated by hyphen, and if we try to apply this method on this string b, then we need to pass hyphen within this parenthesis in order to get the output like this. Because if we don't specify anything, then it will try to split the string based on blank spaces. But here we haven't any space, and it will consider the whole string as a single element. Like if I apply this method like this, and here I'm not going to pass anything within this parenthesis, so it is showing the whole string as one element. In order to get output like this, we need to pass hyphen within this parenthesis, like b dot split, and within parenthesis we need to pass hyphen. So now it is showing the expected output. Now a notable point is this string method returns a list where we have multiple string. Now you can check it by using the type function, that is, if I print type and then within parentheses if I pass this total thing, now note that it is showing list. So list is a collection of data type. We will learn about it in our next video. Now we have another method, that is join. This method is exactly opposite to the split method, because in case of split, it splits the string and gives the output in a list. Here this join method do the reverse process, that is, it first take one list and based on the separator it convert the list into a string. So here we have a list like this, and we want a string like this from this list. So to do that, we need to first specify the separator. For example, here the separator is space, so here we need to pass space, and then we need to write dot and then join, and within parentheses we need to pass the list, that is a. So it will print the string like this. Python programming is easy to learn. So our last string method is format. To understand it, let's assume a scenario where you have a name that is XYZ and age that is 28, and you want to print a statement like this: hello, I am XYZ, my age is 28. But you don't want to pass the name and the age directly, rather you want to store it in a variable. Then you want to use the variable name, that is name and age. But if you write this way, then it will not going to fetch the value of name and age. Like if I print it, so note that it is showing hello, I am name, my age is age. So it is showing the variable names, but it is not showing the actual value of those variables. So to print the values, we have two approaches. So the first approach is we need to first break it in multiple statements, like hello I am is a statement, then we need to give comma, then we need to pass the variable name, that is name, and then we need to again pass this message within a quotation like this, and we need to give again comma, and then we need to pass the last variable, that is age. So now if I print this, so it is showing the expected output, that is hello, I am XYZ, my age is 28. Now if you don't want to break it in multiple statements like this, then you can use this format method. So to do that, we need to write print. Instead of passing the name or the variable name, just open a curly braces and close it, and then again here also open a curly braces and just close it, and then at the end of the statement give a dot and then write format, and within parentheses first pass the first variable name, actually that is name, and then the second variable, that is age. So here I'm passing age. So now if I print it, so it is showing hello, I am XYZ, my age is 28. We have already finished all the primitive data types. Now from this video onwards, we will learn about different collection data types where you can store multiple values in a single variable. In this session, we will learn about list data type. List is one of the most used collection data type in Python because it is similar to the array, although it is more flexible than array. First of all, let's see how to declare a list in Python. To declare a list, we need to first give it a name. For example, here I am giving a, and within square bracket we need to pass values like 10, and you can pass multiple values by separating them with a comma, 10, 20, 30. Now you can also check the type of a, like type of a, so it will be showing list like this. Now let's understand all the features of list one by one. So first of all, list is ordered, which means if you repeatedly print the value of list, then you are always going to get this order only. It is not going to change. Or in other words, you can say, for example, here this 10 is at index 0, and you can always access this element by using indexing concept, and the index of this value will always be 0. It is not going to change. For example, here I am going to print the value of a. Now note that it's printing list in this order only. So next feature is indexing concept is applicable, which means the index value of the first element is 0 and second element has index 1 and so on. And a negative indexing concept is also applicable. For example, we know the negative index of the last element is -1 and the second last element has index -2 and so on. For example, here we have a list b equals to this, and if you want to print this value, that is 3, then you can write b, and within square bracket you can pass the index of this 3, that is 0, 1, 2. So the index of 3 is 2. So if I pass 2, then it will print 3. And you can also use the negative indexing concept, like the negative index of this 3 will be -1, -2 and -3. So if you write b and within square bracket if you pass -3, then it will print 3. So our next feature is you can change the value of the list element. So to do that, we have multiple methods, but you can also use the indexing concept to change the value. For example, if you want to change this element from 7 to 70, then you can use the indexing concept. To do that, we need to first calculate the index of 7, that is 0, 1, 2 and 3. So the index of 7 is 3. So we need to write c, and within square bracket we need to pass the index, that is 3. And then we need to write the new value, that is 70. So if I press enter, and now if I print the list, that is C, so it will be showing the updated list, that is with 70. So the next feature is slicing concept is also applicable. For example, here we have a list a equals to this, and now if you want to print this 4 element by using slicing concept, then you need to first write the list name, that is a, and then within square bracket you need to first pass the index of the first element, that is 0 in our case, and then you need to give colon, and then you need to write the int index plus 1. So in this case our int index is 0, 1, 2 and 3. So our int index is 3, but we need to pass 3 plus 1, that is 4. Now if you press enter, now note that it is showing the first 4 element. Not only you can print multiple values by using this slicing concept, but also you can change multiple values from a list by using this slicing concept. For example, here we have 1, 2 and 3. Now if you want to change it into 10, 20 and 30, then you need to write first the list name, then within square bracket you need to again pass the first index. In this case our first index is 0, so here we need to pass 0, and then we need to give colon, and then you need to pass the end index plus 1. So in this case our end index is 0, 1 and 2, so we need to pass 2 plus 1, that is 3. Then you need to define the new values within a square bracket. So in our case it is 10, 20 and 30. So now if I print the list, so it will be showing the new updated value, that is 10, 20 and 30. Now if you don't know this indexing and slicing concept, then you can check our previous videos where I have discussed about this in a great detail. I will provide the link in the description. Next feature is duplicates are allowed. For example, here we have a list, but within this list we have multiple elements with same value. Now if I print this list, then it will consider these duplicates. So list will not going to ignore these values. For example, if I print v, so it has considered all the duplicates. So our next feature is you can store any kind of value within a list. For example, you can store a integer value like 10, and you can also store a string value like string, and you can also store a float value like 5.5. Not only that, you can also store a list within a list. Like here I'm going to store an inner list, that is 1, 2, 3, 4. Now the question is how to access this inner list. Now to access this inner list, we need to first access this whole list. For example, you want to access this 3 which is present in the inner list. Now to do that, we need to first access the whole list that is present at 0, 1, 2 and 3. So here we need to write a, and within square bracket we need to first 3. Now we are in this inner list. So within inner list we need to access this 3. So we need to write the index of this 3. So this 3 is present at 0, 1, 2. So here we need to pass 2 within another square bracket. Now if I press enter, so it is showing 3. So here we have a 3 into 3 matrix, and we want to store it in a list by using this nested list concept. To do that, we need to first give a name, that is matrix. So within this list we need to store this matrix by row. So we need to first store the first row, that is 1, 2 and 3, and then we need to store the second row, that is 4, 5, 6, and then we need to store the third row, that is 7, 8, 9. So this is how we can store a matrix within a list. Now we will learn different methods that can be applied on list data type. So our first method is append. This method will append a new value at the end of the list. For example, here we have a list 1, 2, 3, and if you want to add another value, that is 4, at the end of the list, so we need to write a dot append, and within parentheses we need to pass the value, that is 4. And now if you print a, so this is our expected output. So our next method is insert method. If you want to insert a value at a particular index, then you can use this method. For example, if you want to add this 4 at the place of 2, that is at index 1, you can use this method. To do that, we need to write a dot insert, and then we need to first pass the index, that is 1, and then the value, that is 4. Now if you print a, so this is our expected output. This method will remove a particular value from a list. For example, if you want to remove this 6 from this list, then you can write b dot remove, and then within parentheses you can pass the value, that is 6. So now it will remove the value 6 from this list b. Now if you print the list b, so 6 has removed. Now if you want to delete an element by using index value, then you can use this pop method. For example, here we have a list that is 1, 2, 3, 4, 5, and you want to delete this 3 by using the index of this 3, that is 0, 1, 2. Then you can use this pop method. To do that, you need to write a dot pop, and within parentheses you need to pass the index, that is 2. Now if you print the value of a, so it is showing this expected output. So our next method is clear. It will remove all the elements of a list. For example, if I apply this method on this list a, like a dot clear, And now if I print the list A, then it will return a empty list like this. This method actually append one list at the end of the another list. For example, here we have two lists, that is A equals to 1 to 3 and B equals to 4 and 5. Now if I write A dot extend B, then this list B will be added at the end of this list A. Now if I print A, now it is showing the updated list. This method will give you the number of occurrence of a value in a list. For example, here 1 has occurred 4 times. So if I write A dot count and within parentheses if I pass 1, then it will show 4 like this. This method will return you the index of a particular value. For example, if you want to know what is the index of this element 5, then you need to write A dot index and within parentheses you need to pass the element, that is 5. Now it will print the index of this element, that is 4. So our next method is reverse. If I apply this method on a list, then it will reverse the elements of that list. For example, here we have a list that is A equals to like this, and now if I apply this method on this list, then it will print all the elements in the reverse order. Now if I print A, so this is our expected output. So our next method is sort. It will sort the list in ascending order. For example, here we have a list A, and now if I apply this method on this list A dot sort like this, and now if I print the list, then it will show the sorted list like this. Next we have a function that is sum. It will return the sum of the elements of a list. For example, if I write sum and then within parentheses if I pass the list that is A, then it will return the sum of the elements. And let me print it. So it is showing the sum, that is 6. This function will return the length of a list or the number of elements present in a list. Now if I write length of A, then it will return the number of elements present in the list A. So it is showing 6. Now remember that all the methods that I have mentioned here will change the original list. Now let's understand about the concept of immutability and mutability. Mutable means we can change the value of a data and it should be accepted by Python. For example, in a list we can change the value. So here we have a list A equals to 1, 2, 3, 4, and this line will print the memory address of this list. And in this line I have changed the value from 1 to 10. And again I am trying to print the memory address of that list. Here note that the memory address of the list before changing the value and after changing the value is same. It means we can change the value of a list and Python support it. So list is a mutable data type, or we can change the value of the list after declaring. On the other hand, we have some immutable data types like all the primitive data types, and some collection data types like tuple are immutable, which means we can't change the value after declaring. For example, here we have an integer value that is A equals to 10, and this line will print the memory address of that variable A. And now here I am going to change the value of A, like A equals to 11, and then again I am trying to print the memory address of A. We know that integer is not a mutable data type, so we can't change the value of it after declaration, but here we have changed it from 10 to 11. Now it will going to create a new memory location for this value, that is A equals to 11. Now if I run this code, you will see that these memory locations are different in both the cases. Let me run it. Now note that the memory locations are different. Our next collection data type is tuple. Here also you can store multiple values within a single variable. To define a tuple, you need to first give it a name. So here I am giving it T, and within parentheses you can store multiple different types of data. For example, you can store an integer data like 10 or a float data like 10.5, and you can also store a string like this. Now you can check the type of t. So type of t, so it will be showing tuple like this. Now let's understand different properties of a tuple. So first of all, indexing concept is applicable. You can access any element by using indexing concept. For example, if you want to print this 4 by using indexing concept, then you need to first calculate the index of 4. So index of 4 will be 0, 1, 2. So index of 4 is 2. So you need to write a, and within square bracket you need to pass the index of 4, that is 2. So here I am passing 2. Now if I press enter, it will print 4 like this. So our next property is slicing concept is applicable, by which you can print multiple data from a tuple. For example, here we have a tuple b equals to this, and if you want to print the multiple values like from 3 to 6, then you can use this slicing concept. To do that, we need to first write the tuple name b, and then within square bracket we need to first pass the starting index. In our case, the starting index is 0, 1, 2. So our starting index is 2. So here we need to pass 2 and then give a colon. Then we need to pass the end index plus 1. So our end index is 0, 1, 2, 3, 4 and 5. So our end index is 5, but we need to pass end index plus 1, that is 5 plus 1, that is 6. Now if I press enter, so it is showing this 4 data. Now if you don't know about this slicing and indexing concept, then you can check our previous video where I have explained it in a great detail. I will provide the link in the description. So our next property is tuple is immutable, which means we can't change the value of a tuple after declaration. For example, here we have a tuple t equals to this. And you can access this element by indexing concept, but you can't change the value of it. If you try to change it, then you will get an error. For example, if I try to change the value of this element from 4 to 40, then we will get an error like t, and within square bracket if we pass the index of this element, that is 3, and then if I try to change it from 4 to 40, then we will get an error like this. Tuple object doesn't support item assignment. Our next property is tuple is ordered. For example, here we have a tuple t equals to this, and throughout your program you will always going to get this tuple in this order only. It will not going to change suddenly. Or in other words, you can say here at index 2 we have this element that is 3, and throughout your program you will always going to get this 3 at this index 2. It will not going to change, and this is applicable for all these elements. In tuple, duplicates are allowed. For example, here we have a tuple t equals to this, and in this tuple we have 4 3 times. But tuple will going to consider all these duplicates. It will not going to remove it. For example, if you print this t, now note that tuple has considered all these duplicates. So our next point is how to declare a tuple with a single value. But before that, let me declare an empty tuple. So if you just write t equals to like this, then it will consider as a empty tuple. You can also check the type like type of t, then you will get as tuple. Now suppose you have a tuple with a single value, so you can declare it as like t equals to, and within parentheses you can pass your single value, that is 5 for example. Now if you declare it like this way, then it will not going to consider as a tuple. You can check the type like type of t, so it will print integer, because we can declare an integer value within a parenthesis also like this way. So to declare a tuple with a single value, we need to write, for example, t equals to, within parenthesis you can pass your single value, that is 5, and then you need to give a comma like this way. Now it will consider as a tuple. You can check the type, so type of t, so it is showing tuple. So this is how we can declare a tuple with a single value. So our next topic is tuple unpacking. If you declare a tuple like this way, then it is known as tuple packing. Now if you want to assign a new variable or different variables for each of these values, then you can use this concept tuple unpacking. So what we need to do is, we need to first give all the variable names within a parenthesis. For example, here I am giving num1, num2, num3 and num4, and then you need to pass the tuple, that is t. Now this num1 will be assigned with this value, that is 1, and num2 will be assigned with this value 2, and so on. Now you can also print this num1, num2, num3 separately. Like if you print like this num1, then it will print 1, and you can also print num2, then it will print 2, and so on. Now we will see different methods that are applicable on this tuple. So our first method is count. It will return the number of occurrence of a particular value. For example, here 3 has occurred 2 times. So now if I apply this method on this tuple, then it will print 2. For example, if I write t.count and within parentheses if I pass 3, then it will print 2. So our next method is index. It will return the index of a particular value. Now if you want to know what is the index of this 4, then you need to write t.index and within parentheses you need to pass the value, that is 4. So it will print the index, that is 4. Now if you want to know what is the index of this 3, then you can write t.index and then you need to pass 3 here. Now it is showing 2. 2 means 0, 1, 2, which means it has considered the first occurrence of that value. So index is going to always give you the index of the first occurrence of that value. It will not going to consider the second or third one. Next we have this length function, which will return the length of a tuple or the number of elements present in a tuple. So if I write length and within parentheses if I pass t, then it will print the length of the t, that is 5. So it is showing 5. Next we have a function that is mean. It will return the minimum value from a tuple. For example, if you want to know what is the minimum value within this tuple, then you need to write mean and then within parentheses you can pass this tuple, that is to t. So it is showing 1 because 1 is the minimum value that is present in this tuple. Similarly, we have this function that is max. It will return the maximum value from a tuple. For example, if you want to know what is the maximum value within this tuple, then you need to write max and within parentheses you need to pass the tuple, that is t. So it is showing 6 because 6 is the maximum value present in this tuple. In this session, we are going to learn another collection data type, that is dictionary, where we can store the data in a key value pair format. For example, if you want to store the age of 3 peoples, then the names are the key and the ages are the value. So let me first explain the syntax. So to define a dictionary, we need to give a name. In our case, I am giving it D, and then within curly braces, you need to pass the elements. So let me define the first element. So first of all, we need to define the key. So in our case, the keys are the name. So this is our key, and then we need to give colon. And then we need to define the value that is associated with this key. So in our case, it is a age. So let me define a age, that is 25. And similarly, let me define another variables. So here I have declared another 2 elements, and this is how we can declare a dictionary. So this is our key and this is the value that is associated with this key, and again this is our value and this is the associated key, and so on. Now let me explain all the properties of dictionary. So first of all, dictionary is ordered. For example, here the value, that is 26, can be accessed by this key, that is B, and throughout your program this key will not going to change, and you can always access this 26 with this key. Like to access this 26, we need to write D, and within square bracket we need to pass the key, that is B. And now if I press enter, it will print 26 like this. So the next property is indexing and slicing concept is not applicable. You can't use the indexing concept on dictionary data type, but you can access the element or the value of each element by using the key, the associated key with this value. Let me show it again. If you want to print the value of 30, then you can access it by using the key, that is C. So you need to write D, and within square bracket you need to pass the key, that is C. So it will print 30 like this. So dictionary is mutable, which means you can change the value of a dictionary after declaration. So we have different methods to change these values, but we can also change the value by using the associated key with this value. For example, here we have an element. So in this element, the value is 25, and we can change it into 20 by using this key, that is A. So we need to write D, and then within square bracket we need to pass the key whose value we want to change. So here we want to change the value 25, so we need to pass the key, that is A. So here we need to pass A, and then we need to define the new value, that is 20. And let me run it again. Print D. So it is showing the updated dictionary. So our next property is duplicates are not allowed, which means you can't define two different values with the same key. For example, here I have declared a key, that is A, and the value associated with A is 24. But here again I have declared the same key with a different value, that is 25. So this is not allowed in case of dictionary. Now if I print D, then it will automatically remove one key. Like if I print D like this, so it has removed this first one, that is A equal A with value 24. So you can't define different values with same key, but you can define the same value with different keys. For example, here we have a key A, and the value associated with A is 25. And here again we have a value, that is 25, that is same, but the key is different. This is applicable. Like if I print D, so it has considered all the value. So now we will learn different methods that are applicable on dictionary. So our first method is keys. So it will return all the keys from a dictionary. So here the keys are A, B and C. Now if I apply this keys method on this dictionary, then it will return all this key. Like if I write d.keys, now so the keys are A, B and C. So this method returns all the values from a dictionary. So if I apply this method on this dictionary, then it will return the values that are 20, 21 and 22. So let me apply this method d.values. So the values are 20, 21 and 22. So our next method is items. This method will return each key value pair as a tuple in a list. So if I apply this method on this dictionary, like d.items, so this is our output. So our next method is get. This method will return the value of a specified key. For example, if you want to know what is the value of this key, that is C, then you can use this method like d.get, and within parentheses you need to pass the key, that is C in our case. Now it will return 22 like this. So our next method is pop. This method will delete one element whose key is written in the parentheses. For example, here if we want to delete this element, then we need to write d.pop, and within parentheses we need to pass the key of this element. So the key is C. So here we need to pass C. Now if I print the dictionary D, then it will show the updated dictionary, that is this. So our next method is clear. It will remove all the elements from our dictionary. Now if I apply this method on D like this, d.clear, and now if I print D, it will show a empty dictionary like this. So our next method is copy. Copy method will return a copy of a dictionary. For example, here we have a dictionary D, and now if I write d.copy, and if I store it within another variable, that is f, and after this line we can use this dictionary by using this name also. Okay, so now if I print f, so it is showing the dictionary. So our next method is update. By using this method we can update a dictionary. For example, here we have a dictionary equals to this, And if I want to update it with this dictionary B, then we can use this method like a dot update, and within parentheses we need to pass the new dictionary, that is B. So here I am passing B, and now if I print A, then it will be showing the new updated dictionary. So our last method is pop item. It will remove the last inserted element. For example, in this dictionary A, the last inserted element is D. So if I apply this method on this dictionary A, then it will remove this element D. So if I write a dot pop item, and now if I print the dictionary A, so it is showing the dictionary without this element, that is D. You can declare an empty dictionary like this way, and if you print the type of D, then it will be showing dictionary or dict. We can also declare nested dictionary. For example, we want to store student database where you want to store name, roll number and CGPA, then you can use this concept nested dictionary. To do that, we need to write the dictionary name, and then within curly braces, let me first declare the first key, that is A. Here the first key, that is A, is the student name, and then let me declare the value. In the value field, we are going to declare another dictionary where we will store the CGPA and the roll number. So the roll number is, so the value of the roll number is, for example, 101, and then let me declare the another element of the inner dictionary, that is CGPA, and the value of the CGPA is 8.5. And similarly, we can declare another element of the outer dictionary like this. Let me copy it and then let me paste it. So here the student name is B and the roll number is 102 and the CGPA is 8.6. So now if I print D, so this is our expected output. So our next data type is set. It is also a sequential data type where you can store multiple items within a single variable. Now first of all, let me define a set. To define it, we need to give a name. So here I am giving it S, and then within curly braces you can store any value. Like you can store an integer value, or you can store a float value, and also we can store a string like this, and then you can also store a tuple within it like 1, 2, 3, and that's all. Now you can check the type of S, so it will be showing set like this. Let's understand different properties of a set. For example, set is unordered, which means it doesn't has any specific order. So if you try to print this set, then there is no guarantee that it is going to print in this order only. So let me print it. So note that the order has changed. So the next property is duplicates are not allowed, which means set doesn't allow duplicates. For example, here we have a set S, and within this set we have 10 3 times. So now if I try to print this S, then it will automatically remove the duplicates. So let me print it, print S. Now note that here we have 10 only one time. So the next point is indexing and slicing concept is not applicable. Now if you try to print this element by using slicing concept, then it will raise an error like S, and within square bracket if I pass the index of this 6, that is 0, 1, 2, 3, 4, then it will raise an error. Like this, set object is not subscriptable. Set is mutable, which means you can add a new value after declaration, and you have different methods to do it. So here we have a set S is equal to 1, 2, 3, 4, and now if you try to add 10 within this set, then you can write S dot add, and within parentheses you need to pass the new value, that is 10. And now if I print, so it is showing the updated set. Now let's understand different methods that are applicable on set data type. Now here the first method is add. So already we have seen it, but let me show it again. This method is basically used to add new value after declaration. So to add a new value, we need to write as the set name and then write the method name, that is add, and then within parentheses we need to pass the new value. That is, for example, here I am trying to add 10, so let me pass 10, and now if I print the as, so it is showing the updated set. So our next method is copy. It will create a copy of a set, after which you can use this new name to use this set. For example, if I write p equals to s dot copy, and now from onwards you can use this name, new name p, to print this set. For example, if I write print p, so this is our output. So our next method is clear, and this method will remove all the elements from a set. For example, if I apply this method on this set s, like s.clear, then it will remove all the elements, and now if I print the set s, then it will return a empty set like this. So our next method is discard. It will remove one element from a set. For example, if you try to remove this 4 from this set, then you can use this discard method. To use it, we need to write s.discard, and within parentheses we need to pass the value, that is 4. And now if I print s, so it has successfully removed this 4. So our next method is intersection. It will return a set where we have the intersection or the common elements from two sets. For example, here we have two sets, and the common elements between two sets are 3 and 4. So if I apply this method on these sets, then it will return 3 and 4. For example, if I write a dot intersection, and then within parentheses we need to pass another set, that is b, so it is showing 3 and 4. So our next method is union. It will return a set where we have all the values from two sets. For example, here we have two sets, and if I apply this union method on these two sets, then it will return a set where we have all these values. So a dot union, and within parentheses we need to pass the another set, that is b. So this is our output. So our next method is disjoint. It will return whether two sets have intersection between them or not. If there exist any common elements between two sets, then it will return false, otherwise it will return true. So we have these two sets, and here these two sets have some common elements, that are 3 and 4. So if I apply this method on these sets, then it will return false. So let me do it. A dot is disjoint, so it is showing false. So our next method is superset. It will return whether this set contains another set or not. For example, here we have two sets, that are A and B, and all the elements in B can be found in set A, that is 3, 4 and 5. So if I apply this method on these sets, then we will get true. Like if I apply a dot is superset, and then within parentheses if I pass the set, that is B, so it is showing true. So our next method is subset. It will return whether this set is a subset of another set or not. For example, here we have a set B, and this B can also be found within this set A. So this B is a subset of A. So if I apply this method on B, like B dot is subset, and then within parentheses if I pass A, then it will be showing true, like this. So our next method is remove. It will remove the particular element. For example, if you want to remove this 4, then you can write a dot remove, and then within parentheses you need to pass the element, that is 5. And now if I print a, so it has successfully removed this 5. So our next method is pop. This method will delete one element randomly, and it returns that element. So if I apply this method on set A, like a dot pop, then it will remove one element randomly, and let me store that element in B. So now if I print A, so note that it has removed 1, and this 1 is stored in B. So let me print B like this. So our next data type is frozen set. As the name suggests, it is frozen, which means we can't change the value after declaration, or you can say it as the immutable version of a set. Now we don't have any facility to declare it directly, so we need to first declare a list or a set, then we can typecast it into frozen set. So here we have a list, and let me declare a frozen set. So af equals to frozen set. You need to use this function, that is frozen set, and then within parentheses you need to pass the list, that is s. So now if you check the type, then it will be showing frozen set like this. As it is the immutable version of a set, so we can use all the methods on frozen set that are applicable on set, except those methods which modify the value, because frozen set is immutable. For example, add method adds one element, which means it changes the value. So we can't use this method on frozen set. For example, here we have a frozen set that is p equals to like this 1 2 3 4, and if you want to add one element by using add method, then you will get an error. For example, if I write p dot add 10, then it will raise an error like this. Frozen set object has no attribute add. But isDisjoint method only checks whether there exists an intersection between two sets or not. It is not going to modify anything. So we can use this isDisjoint method on this frozen set data type. For example, here we have two frozen sets that are p equals to 1 2 3 4 and q equals to 3 4. So there exists an intersection. So if I apply this method on this frozen set data type, so we will get false. So let me do it. P dot is disjoint, and within parentheses if I pass q, then it will print false like this. Here I want to mention one more thing, that is if you want to declare an empty set, and if you declare it like this way, then it is not going to consider as a empty set, because if you check the type, then it will be showing dict. So what you need to do is, if you want to declare an empty set, then you need to write s, and then you need to write set, and then like this way. If you declare it like this way, then it is going to consider as an empty set. Now you can check the type, so it will be showing set like this. So in this video, we are going to learn rest of the data types in Python. So first one is range data type. To define it, we need to use range function, which will return a range of value. Now let me define it first. To define it, we need to give a name. So here I am giving it p, and then you need to use range function, and within parentheses you need to pass the range. Here I am passing 10. I will discuss about these parameters in a great detail, but for now let me just pass 10. And now if I print the type of p, then it will be showing range type like this, type of p. So it is showing range type. Now the question is, what does it mean by range of 10? Actually, you can think of it as a collection of numbers from 0 to 9. Now let me print this p. So it is showing 0 to 10. But here 10 is excluded. It will take up to 0 to 9. And the default step value is 1. That's why it includes all the numbers from 0 to 9. The actual syntax of this range function is like this. Here we need to write start value first, and then we need to write end value plus 1, and then we need to define the step value. Now here the step value is optional. If you don't write it, then it will automatically take the default value, that is 1. This range data type is basically used with for loop. We will again come back to this range data type when we will be dealing with for loop. So our next data type is byte data type. Here also we don't have any direct way to define a byte data type. To declare a byte data type, we need to first define a collection data type like list or an integer. But it is quite different from other data type. Let me explain it clearly. So we have a list and we want to convert it into byte data type. So we need to first give a name. So here I am giving it as b, and then we need to use the bytes function. And within parentheses we need to pass the list, that is L. Now if I print the type of b, then it will be showing bytes like print type of b. So it is showing bytes data type. Now let me print this b. So print b. So here this B represent it is a bytes data type, and this /x is a escape character, which means these next two digits are in hexadecimal form. Here I have written down some hexadecimal form of a decimal value, like hexadecimal form of 1 is 1, and hexadecimal form of 2 is 2, and the hexadecimal form of 11 is B. So here it is showing the hexadecimal values of these elements in list. Like 01 is the hexadecimal form of 1, or this is 2, and so on. Now one more thing is we can store only up to 255, which means if you store any value which is greater than 255, then it will not going to be converted into bytes data type. For example, here we have a list that is T, and within this list, let me store some values that are greater than 255, like 260, 300, 400. And now if I try to convert it into a bytes data type, then it will raise an error, like let me define a name that is R and then bytes, and within parentheses let me pass T, and now if I press enter it will raise an error like this. Next is if we pass an integer value within bytes function, then it will create a list of that size and fill it with zeros. So here we have an integer value that is a equals to 6, and now let me define this bytes function and bytes, and within parentheses if I pass this integer value that is a. Now if I print it, so this is nothing but the bytes object of list. You can also verify it by converting it into list. We will see this conversion in a great detail in our next video, but for now let me convert it into list, like e equals to list of, and within parentheses if I pass this bytes for bytes object that is b, and now let me print it. So it is showing a list of length 6 and all the elements are 0. Finally, if you try to pass a string value, then you need to pass two more things within this parenthesis. First of all, we need to pass the string. So here we have a string a equals to this. So here I am passing a, and then we need to pass the encoding scheme in which we want to encode the string. So I want to encode it into ASCII. So here I am passing ASCII, and then finally we need to pass the error, which will handle the conversion when it will fail. Typically, we have three error handling scheme. First one is strict, which means if it doesn't find the encoding of any character in the particular encoding scheme, then it will raise an error and the conversion will stop. For example, here we have this character like this, and in ASCII we don't have the encoding of this character. So here if I pass strict like this, then it will raise an error like this. Second one is replace. You can replace with question mark whose encoding is not present in that particular encoding scheme. For example, here the encoding of this character is not present in this ASCII encoding scheme. So here if I write replace, now let me run it, and now if I print B, so note that this character is replaced with question mark. Finally, we have ignore, which means it will ignore that particular character. So we don't have the encoding of this character. Now if I write ignore in error handling part, then it will simply ignore this character. So let me print the B. So note that it has ignored this character. The next point is indexing and slicing concept is applicable on this data type. For example, here we have a bytes object like this, and if you want to access this element, like if you want to access this 2, then you need to write b, and within square bracket you need to pass the index of this 2. So the index of this 2 will be 0 and 1. So here we need to pass 1, and now if I press enter, now note that it is showing 2. So the next point is it is immutable, which means you can't change any value after declaration. For example, here at index 0 we have this value 1. Now if you try to change it by indexing concept, then you will get an error like b of 0, and now if I try to change it from 1 to 10, then we will get error like this. Bytes object doesn't support item assignment. So our last data type is byte array. It is nothing but the mutable version of this bytes data type. We have seen that bytes data type is immutable. So it is nothing but the mutable version of this data type. So we can change the value of this data type after declaration. For example, here we have a list like this. And now if I declare the byte array like b equals to byte array, and then within parentheses we need to pass this L, and let me print it. And now if I try to change the value of this element from 2 to 5, then we can do it happily. Like b of within square bracket we need to pass the index of 2, that is 1, and then we need to write the new value, that is 5. And note that it hasn't raised any error. So in this session we will discuss about typecasting in Python. Typecasting means type conversion from one data type to another. For example, you can change an integer data into a string or a list. So these are the functions by using which you can change one type of data to another. For example, here we have a function str. By using this function you can change any kind of data into string. But always remember that you can't change any collection data into a primitive data type. For example, you can't change a list into an integer or a float. Okay, but you can change it into string data type. Similarly, you can't change any other form into dictionary. Like you can't change a list or a tuple or a set into dictionary. For example, here we have an integer value that is 10, and you can typecast it into float. To typecast it, we need to first store it in a variable like b and then write float, and within parentheses you need to pass a. And now if you check the type of b, then it will be showing float. Type of b, so it is showing float. Similarly, for example, we have a list like this 1, 2, 3, 4, and you can typecast it into a tuple. Like let me store it in t and then tuple. Now if you print the type like type of t, then it will be showing tuple like this. And also you, for example, we have a integer value that is b equals to 20, and you can typecast it into a string like c equals to str of b. Now if you check the type, then it will be showing string like this. Now you may think, why this typecasting? Here I want to give you two examples where you can find this typecasting very useful. So first one is, for example, we have seen that in case of a list data type, we have a method sort, which returns the list where we have all the elements in ascending order. But if you are using a set data type, then we don't have this facility to sort a set. So if you try to sort this set by using sort data type like s.sort, then you will get an error like this. So by using typecasting, you can first typecast this set into a list like this way: L equals to list of s, and then you can sort this list like L dot sort, and now our elements are sorted. And then again you can typecast it into a set like d equals to set of L, and now if you print d like this way, so it is showing our sorted set. Next example is basically a question where you have a list, and within this list you have duplicates value, like we have 1 4 times and 4 2 times and 9 2 times. So you need to remove these duplicates and you need to keep one instance of each elements. The first approach to do this, you can create an empty list and then start filling with the values from the filled list. And before filling, check whether the current value already exists in that new list or not. But Python already provides us an inbuilt data type which ignores the duplicates, which is set data type. By using typecasting, we can solve this problem in a single line. So what we need to do is, we need to first typecast this list into set, like s equals to set of this list, that is a. And now it will remove all the duplicates, and then again typecast it into list like L equals to, and now if I print this new list, that is L, So this is our expected output. Operators are generally used to perform different operations on variables. These are the standard symbols which represent the type of operations. So these are the operators that are present in Python. We will learn all of these in a great detail. So let's start with arithmetic operators. In this type, we have 7 operators, that are addition, subtraction, multiplication, division, modulus, float division, and exponential. We can use this operator on some particular data type, and based on that, it will give the output. First of all, let's understand addition operator. So it's simple. If I apply this operator on integer data type, then it will give the sum. For example, if I write 2 plus 3, then it will give 5. Not only that, you can also use this operator on float data type like 2.5 plus 3.5. So it will give 6.0. Now this addition operator is also applicable on a string data type. For example, here we have a string like a equals to Python, and we have another string that is b equals to programming. Now if I apply addition operator on these string values, then it will append the second string at the end of the first string. So let me do it. So we will get output like this, and this concept is also known as string concatenation. But always remember that if you want to use addition operator on a string data type, then all the operands should be string. For example, we have a string data like a equals to Python, but I'm trying to apply this addition operator on this string value a and integer value 4. Then we will get error like a plus c. So it is showing error, can only concatenate string to string. Similarly, this addition operator is also applicable on collection data type. For example, we can use this operator on list data type. So here we have two lists, and if I apply addition operator on this a and b, then it will create a new list where we will have all these elements. Like if I write a plus b, so note that here we have all the elements from both the list. So our next arithmetic operator is subtraction. This operator is only applicable on numeric data type. For example, if I write 10 minus 5, then it will return 5. And also we can use it on float data type like 10.5 minus 5. So it is showing 5.5. And this operator is not applicable on string or any collection data type. Next we have multiplication. You can use it on numeric data type. Like if I write 10 multiply 2, then it will return the multiplication, that is 20. And also you can use it on float data type like 10.5 multiply 4. So this is the output. Now multiplication is also applicable on string data type, but here one important thing is you can't use multiplication operator on two string data. For example, here we have a string that is Python like this, and another one is programming. And now if I write a multiply by b, then it is showing the error, that is can't multiply sequence by non-end of types str. But you can use this multiplication operator on a string and an integer value. Then it will repeat the string. For example, here we have a string that is Python and an integer value that is 3. And if I apply this multiplication operator on that, like a multiply b, then it will repeat this string that is Python 3 times. So this is our output. Same thing is also applicable for a collection data type. For example, here we have a list like a equals to 1, 2, 3. And we have an integer data like b equals to 3. And now if I write a multiply b, then it will repeat the elements 3 times. So this is our output. Our next operator is division, and this operator is applicable on numeric data type only. For example, if I write 10 divided by 2, then it will print 5.0. Now note that this division operator returns the output in float data type only. Next we have float division. Float division is a normal division operation except that it returns the largest possible integer. For example, we want to divide 25 by 2. So if I write 25 divided by 2, so here I am using the normal division operator or the simple division operator. So it is showing 12.5. But if I use float division instead of this division operator, like 25 float division 2, so it is showing the largest possible integer number, that is 12. And here always note that this division operator returns the value in float data type, but the float division returns the value in int data type. We can also check it like type of (25) float division 2. So here note that it is integer data type. Our last arithmetic operator is exponential operator, which is represented by two multiplication sign. If you want to represent 1000 in the form of 10 to the power 3, then you can use this operator. So we need to write a, and then we need to write 10, and then use this exponential operator, that is 2 times multiplication sign, and then you need to write the power, that is 3. And now if I print a, then you will see it will print 1000 like this. So we have already finished all the arithmetic operators. Our next category of operator is assignment operator. Assignment operator is basically used to assign some value within a variable. For example, we have a variable a, and now if I want to store some value within it, then we need to write this assignment operator, and then we can assign the value, that is 10. So this is how we can use this assignment operator. So you can use this assignment operator with the addition of some other operator, which is also known as compound assignment operator. For example, you want to add 5 with a, so you can write it like this way, and again you want to store this result in a, so you can write this way. Now if I print the value of a, then it will be showing 15 like this. But you can use compound assignment operator instead of this. So you need to write a, and then you need to write plus, and then write the assignment operator, and then write a. So this thing and this thing are similar. We can also check it. And now if you print a, then it will be showing 20. In this session, we are going to learn about relational operator. In this category, we have 4 operators that are less than equal to, greater than, and greater than equal to. So let's start with less than operator. It will return true if the left operand is less than the right operand. Otherwise, it will return false. For example, here the left operand is 5, and then I am applying this operator, that is less than, and our right operand is 7. So here the left operand is less than the right operand, so it will return true. So our second relational operator is less than equal to. It will return true if the left operand is less than or equal to the right operand. For example, here we have 4 as the left operand, and here I am using this less than equal to sign, and then our right operand is also 4. So if I press enter, it is showing true because the left operand is equal to the right operand. So our next relational operator is greater than. It will return true if the left operand is greater than the right operand, or otherwise it will return false. For example, here we have 10 as the left operand, and then I am applying this greater than sign, and 4 as the right operand. So it is going to print true because the left operand is greater than the right operand. Our last relational operator is greater than equal to. It will return true if the left operand is greater than or equal to the right operand. For example, here we have 10 as the left operand, and then here I am applying this greater than equal to operator, and our right operand is 7. So here this left operand is greater than the right operand, so it is going to print true. And also if I write 10 and greater than equals to 10, then also it is going to print true because here 10 is equals to 10. You have already seen that these operators can be used on numeric data type. For example, you can also use these relational operators on Boolean value. Like if I write true greater than false, then it is going to print true, because true is similar to 1 and false is similar to 0. But remember that we can't use relational operators on complex data type. If you try to use this, then it is going to raise an error. For example, here we have a complex value like 3 plus 4j, and we have another complex value that is b equals to 5 plus 7j. Now if I use this relational operator, that is a greater than b, then it is going to raise an error like this. So the next point is we can use these operators on string data type also, but the question is how will it be compared? So the comparison will be done based on the Unicode of the first alphabet. So here we have two string value, that is a equals to apple and b equals to apple. But note that in this case this a is in lowercase and here this a is in uppercase. We know that the Unicode of the lowercase a is 97 and the Unicode of the uppercase a is 65. So here it is 97 and here it is 65. So if I write a greater than b, then it is going to print true, because here a is 97 and here a is 65, like this. But one important thing is you can't compare a string value with a numeric value, then it will raise an error. For example, here we have a string value like a equals to apple and we have an integer value like b equals to 10, and if I write a greater than b, then it is going to raise an error like this. You can also use these relational operators on collection data type. For example, you can use these operators on tuples. Then it is going to compare the first element of each tuples and based on which it will return the result. Now if I compare these tuples like a is greater than b, then it is going to print false, because here the first element is 1 and here the first element is 7. So a is less than b. So here if I write a greater than b, then it is going to print false. Now what will be the answer whenever we have more than 2 operands? For example, here we have 4 operands. So what will be the answer? In this scenario, the result will be true if and only if all the result of each comparison will become true. For example, here we have 3 greater than 2. So the result will be true because 3 is really greater than 2. And the result of the second comparison will be false because here 2 is less than 1. So it is not correct. So the result of this second comparison will be false. And the last comparison is 1 is less than 10. So it is also true. So the result of this last comparison is going to true. But here the result of the second comparison is false. So the ultimate value or the ultimate answer will be false, like this. So our next category of operator is equality operator. Here we have two operators that are equal to operator and not equals to operator. So let's start with this equal to operator. It will return true if both the variables contain same value. For example, here we have a variable a equals to 10 and here we have another variable that is b equal to 10, and if I apply a equal to b, then it will return true because both the variables contain same value. But if I apply 5 equal to 6, then it will return false because both the values are different. You can also use this operator on collection data type. For example, here we have a list like this 1, 2, 3, and here we have another list that is, and if I apply equal to operator on this list data type like a equals to b, then it will return true because both the variables contain same value, that is 1, 2, 3. You can also use it on string data type. For example, here we have a string value that is Python, and here we have another string value that is Java. So if I apply a equals to b, then it will return false. But here we have another variable, for example Python. So if I write a equals to c, then it will return true. So our next equality operator is not equal to operator. It will return true if the variables contains different values. For example, here we have a equals to 10 and b equals to 12, and if I apply not equal to operator on a and b like a not equals to b, then it will return true. So this is the not equal to sign, but if I apply 5 not equals to 5, then it will return false. Similarly, you can also use this operator on string or any collection data type. And here also, if you have more than 2 operands, then the result will be based on each comparison. If the output of each comparison is true, then finally we will get true. For example, here we have a expression like 1 equals to 1, then 1 not equals to 8, and then 8 equals to 2. So the first comparison is 1 equals to 1, so the answer will be true. And the next comparison is 1 not equals to 8, so this is also true. And the last comparison is 8 equals to 2, but this is false. So ultimately we will get false because the result of this last comparison is false, like this. But if we have an expression like this, 1 equals to 1, then 1 not equals to 9, then 9 equals to 9. And now if you check, then you will find that the first comparison, the result of the first comparison will be true, and the next comparison will be true, and the last comparison is also true. So ultimately we will get true, like this. In this session, we are going to learn about logical operators in Python, in which we have three operators that are AND, OR, and NOT. We will first see each of them for Boolean data type, which means what will be the output when we apply these operators on Boolean value. And then we will see for non-Boolean values. So this is the table for AND operator, and here note that whenever we have all the values true in this case, so the output is going to true. But apart from that, whenever we have any of the value is false, then the output is going to be false. So let me verify it. For example, here I am passing false as the first operand, like this, and here I am using this AND operator, and here I am passing true, like this. So the output is false because here one operand is false. So let me try another one, that is if I write true and true, then it is going to print true because here all the operands are true. Or for example, if I write false and false, then it is going to give false as the output, like this. So this is the table for OR operator. Here note that if all the values are false, then only we will get false, otherwise we will get our output true. Or you can say if one of the value or expression evaluates to true, then it will return true no matter what is the value of other operands. So let me verify it. So if I pass true or false, so here our one operand is true and another one is false, so it is going to print true because here one operand is true. So if I pass false or false, then it is going to print false, and this is the only one case where we will get false as our output. Now our last logical operator is NOT operator. It is very much simple that it reverses the Boolean value. Like if I apply NOT on false like this, then it is going to reverse it, so it will return true. Or if I write NOT and within parentheses if I pass true, then it will return false, like this. This is all for the logical operator on Boolean value. Now we will see for non-Boolean data type. It is quite confusing, but I will explain it in a simpler way. Just listen carefully. So before going to the topic, just keep it in your mind that 0, empty list, empty set, and these kind of values are similar to false. And other than that, all the values are similar to true. For example, an integer value or a float value or a string value is similar to true. Here we have the table for AND operator. If I give you all the operands, then immediately you can able to tell what will be the answer by looking at this table. But my question is, can you guess the answer by looking only one operand? So let me just hide this second operand. Now here we have false, but we don't have the second operand. But we know that the output of the AND logic will be true if and only if all the operands are true. Otherwise it will return false. So from this we can conclude here the first operand is false, so no matter what is the value of second or third operand, the answer will always be false. So this is our first observation. Coming to the next observation, here we have true as one of the operand, but we don't know the other operand. Then what will be the answer? Or can you conclude something from this operand? The answer is yes. You can think about it like this way. Here the first operand is true, so it gives green signal to the AND operator to print true as the output. But it is not sufficient to print true because we need the second operand also in order to identify the output. But at this moment we can say that now the output is totally depends on the second operator, because if the second operator is true, then the output will be true, and if the second operator is false, then the output will be false. Because we know that in case of AND operator, if any of the operand is false, then the output will be false. In this case it is false, so our output will be false. So this is our second observation. Now observe the third point. Here the second operand is false. So no matter what is the value of first operand, the answer is always going to be false. Because in case of AND operator, we know that if any of the operand is false, then the final answer will be false. And in the last point, we have true as the first operand. So our output will be same as the value of second operand. Here it is true, so the output will be true. So let's execute some code. For example, here we have an empty set like this, and here I am applying this AND operator, and here we have an integer value, that is 10. So what will be the output? So this empty set is nothing but similar to false, and this integer value is similar to true. So we have false and true. So here one of the operand is false, so the answer will be false. And here false is similar to this empty set, so our answer will be empty set like this. Now you may thinking it is simple, that here we have true and here we have false, so the ultimate answer will be false. And here false is similar to set, so we will get this empty set. Then why I have explained so many things few minutes back? Now guess the answer. For example, here we have 10 as one of the operand, and here I am applying this AND operator, and here we have this list, but this list contains some elements like this. Now what will be the answer? Now here we have an integer value and a non-empty list, but both the elements are similar to true. So what will be the answer? So the first operand is similar to true, so it will give green signal to the AND operator to print true as the output, but it is not enough reason to print true. So now our output is totally depends on the second operand. So the answer will be same as the second operand, that is the list. In our case, it will going to print the list like this. So let me give a quick explanation on OR operator for non-Boolean values. In case of OR operator, it will give always true if any of the operand is true, and it will print false if and only if all the operands are false. So here we have an expression like, for example, here we have an empty set like this, and here I am applying this OR operator, and here we have an integer value like 10. So what will be the output? So this empty set is similar to false, so now we can't say anything about the result. So our result is totally depends on the second operand. So our output will be the value of the second operand, that is 10 in our case. So if I press enter, so note that it is showing 10. Now we have another expression like this, where we have 0 as the first operand, and then I am applying this OR operator, and then we have an empty list. So here both the elements are similar to false. So what will be the output? Here first operand is false. So in case of OR operator, we can't say anything, because if the second operand is true, then the result will be true. Or if the second operand is false, then the result will be false. So the answer is totally depend on the second operator. So in this case, the second operator is list. So we will get this empty list as the output like this. In case of NOT operator, it is easy. If we pass any value like 0, empty list, or empty dictionary, or the values which are similar to false, then it is going to give true. For example, if I pass an empty set like this, which is equal to false, then it is going to print true like this. Or if I pass any integer value like this, and this integer value is nothing but similar to true, then it is going to print the reverse of it, which is false like this. So we have already seen all the logical operators for Boolean values and as well as for non-Boolean values. Now let's solve this expression. So here we have this empty set, which is similar to false, and here I am using this AND operator, and here we have this 0, which is also similar to false. So here we have false, and no matter what is the value of the second operand, AND operator is always going to give the result as false. So we have false from this expression, and here we have 5, which is similar to true. Now note that in case of OR operator, we don't say anything if the first operand is false, because we know that in case of OR operator, if the second operand is true, then the answer will be true, because if any of the operand is true, then the answer will be true in case of OR operator. So from this we can't say anything about the ultimate result. But here we have 5, so the answer will be 5 because the result is totally depends on the second operand. So the answer will be 5, like this. In this session we are going to learn about identity operator in Python. As the name suggests, this operator is related to the identity of a variable. Here we have two operators, that are is operator and is not operator. So let's start with is operator. It will return true if all the operands points to the same location. For example, we know that in Python we have the concept of reusability, which means if I create an integer variable like a equals to 10, and then if I try to declare another new variable but with the same value, for example b equals to 10, now we know that for a new object with value 10 will be created. But for b, Python will not create a new object, rather it will point to the existing object, which is created by variable a. So we can say that a and b are pointing to the same object, or they are pointing to the same memory location. So if I apply is operator on a and b, then we will get true. For example, if I write a is b, then it will return true, like this. Now coming to the second example, here we have an integer value like a equals to 10, and we have a string value like b equals to 10. So these two things are different. So if I apply is operator, then it will return false. For example, if I write a is b, then it will return false, like this. Now guess the answer. Here we have a list a equals to 1, 2, 3, and here again we have a list b equals to 1, 2, 3, and here I am applying is operator. So what will be the answer? If you are thinking that it will return true, then you are wrong, because this reusability concept is only applicable for primitive data types, that are integer, float, boolean, string, and complex. So if you declare two different lists with same value, then Python is going to create two different objects in spite of having same elements in both the list. So if I press enter, so note that it is showing false. Now is not is the another identity operator, which is basically opposite to the is operator, which means it will return true if both the variables point to different object in memory. So here we have two different integer value like a equals to 10 and we have b equals to 20. Now if I apply is not operator on a and b, then it will return true because both the elements have different values. Like a is not b, then it will return true, like this. Now the next point is operator versus equal to operator. In case of equality operator, we have seen that this double equals to operator return true if all the operands contain same value, otherwise it will return false. Then what is the difference between equal to operator and is operator? For example, here we have integer value like a equals to 10 and we have b equals to 10. And now if I write a equals to b, then it is going to print true. And if I use a is b, then also it is going to print true. Then where is the difference? Now listen carefully. Double equal to operator compare the value only, and is operator compare the memory location. For example, we have seen that in case of list, for example, here we have list like this 1, 2, 3, and we have another list b equals to 1, 2, 3. Now in this case, if I apply is operator a is b, then it will print false because these lists are pointing different memory location. But now if I apply double equal to operator on a and b, then it is going to print true because both the elements or both the list contain same value. So this is the difference. Our next category of operator is membership operator or in operator, which is used to check whether a value or an object is present in the particular sequence or not. For example, here we have a list like a equals to 10, 20, 30. And if I want to know whether this 20 is present in this list or not, then we can write 20 in A. So it will print true because 20 is present in this list A, like this. But if I try to check whether 50 is present in A, then it will return false because A doesn't contain 50, like this. Our last operator in this session is ternary operator. This operator works on 3 operands. For example, here we have A equals to 10 and B equals to 20. Now if I want to print true if B is greater than A, else we want to print false. So to do that, we need to write first the expression, that is B equals to A. So this is our expression, and if it evaluates to true, then we need to print true. So here we need to write true. This is our first answer, and here we need to write if. So if this condition satisfied, then it will going to print this answer, and if not, then it is going to print this, the second one, that is false. So this is one operand, this is one operand, and this is one operand. So this is the syntax of ternary operator. So we need to write the expression like this, and if this expression is going to true, then it is going to print this answer, or if it evaluates to false, then it is going to print this answer, that is false. So if I press enter, so note that it is showing true because B is greater than A, because 20 is greater than 10. You can also use nested ternary operator. For example, now we want to find the greater number from 3 values. So here we have 3 numbers that are A equals to 10, B equals to 20, and C equals to 30. So we need to write A greater than B. This is our first expression, and if this expression evaluates to true, then it is going to give A as output. Now here note that here we did not check for C. So here we need another expression like A greater than C. And now if this both the expression evaluates to true, then only our answer will be A. So here I am using AND operator because AND operator gives true if and only if both the operands are true. So now if this total expression gives true, then only our answer will be A. So this is our first part. In the next part, I am going to create another ternary operator or the nested one, that is here I am checking if B is greater than A and also B is greater than C, then it will return B as our output, like this. And if this expression evaluates to false, then it is going to return C as our output, like this. And now if I press enter, you will see that our answer will be C or 30, like this. In this session, we are going to learn about bitwise operator. In Python, bitwise operators are used to performing bitwise calculations on integer. The integers are first converted into binary, and then operations are performed on bit by bit. Hence the name bitwise operator. Then the result is returned in decimal format. So first of all, we will learn some concepts of binary number system. But note that I am not going to discuss all the concept of binary number system. Rather, we will learn some of the topics which are required to understand this bitwise operator. So our first point is conversion of a decimal number into binary number system. To convert a decimal number into binary, we need to repeatedly divide the decimal number by 2 until we get 1 as the quotient. So here we have 50, and if we divide it by 2, then we will get 25 as the quotient and 0 as the remainder. Again, if I divide 25 with 2, then we will get 12 as the quotient and 1 as the remainder. We need to repeatedly divide it by 2 until we will get 1 as the quotient. So again divide this 12 by 2, which will return 6 as the quotient and 0 as the remainder. Now divide this 6 by 2, and now we have 3 as the quotient and 0 as the remainder. Again divide this 3 by 2, then we will get 1 as the remainder and 1 as the quotient. So we got our quotient as 1, which means we need not to divide it further. And we need to note down the answer like this manner. So the answer will be 110010, and these each digits are known as bits. So the next point is conversion of a binary number into its equivalent decimal number. So let's take this binary number, and first of all we can index these each digits or bits from right to left like this way. Here we need to follow one formula, that is binary bit multiplied by 2 to the power index value. For example, here we have the binary bit 0, and now we can write 0 multiplied by 2, and the power of 2 will be the index value. In our case it is 0. Similarly, we need to do it for all the bits like this way. Now add them up and we will get 50 as the answer. So 50 is the decimal value of 110010. Now the question is, how many binary numbers can be represented by 2 bits? So by using 2 bits we can represent up to 3 like this. And the formula is 2 to the power number of bits minus 1. For example, by using 8 bits we can represent up to 255. Our next topic is ones complement. For example, here we have this binary number, and if you want to find the ones complement of this number, then you need to just flip the bits, and this is our answer, or 1100 is the ones complement of 0011. Next we need to learn the addition process of binary number system. But before that, you need to keep these points in your mind, that if you add 0 with 0, then the sum will be 0 and also the carry will be 0. Or if you add 1 with 0, then the sum will be 1 and carry will be 0. And finally, if you add 1 with 1, then we will get 0 as the sum and 1 as the carry. Keep these 3 points in your mind. Now we have 101 and 010, and the addition will start from right to left. So first of all, we need to add 1 and 0. Then we will get 1 as sum and 0 as carry. Next we have 0 and 1. And if you add them, here also we will get 1 as sum and 0 as carry. And finally, we have again 1 and 0. So we will get 0 as the carry and 1 as the sum. So the answer is 111. Now let's solve another problem. So here we have 1010 and 1111. So if we add 1 with 0, then we will get 1 as sum and 0 as carry. Next we have 1 and 1. So if we add 1 with 1, then we will get 0 as sum and 1 as carry. Now this carry that is generated here, we need to add this carry with the sum of these next two digits. So if we add 0 with 1, then we will get 1 as sum and 0 as carry. But note that we need to add this sum with the carry that is generated in the previous 2 bits. So if we do so, then we will get finally 0 as the sum and 1 as the carry. And then we need to add 1 with 1, and again we will get 0 as the sum and 1 as the carry. But note that we need to add this sum with the carry that is generated in the previous bit, that is 1. So if we do so, then we will get finally 1 as sum and 1 as carry. Now we don't have any bits, so this carry will set here like this way. So the final answer will be 11001. So our next topic is 2's complement. For example, here we have a binary number that is 0011, and if you want to find the 2's complement of 0011, then you need to first find the 1's complement like this, and then you need to add 1 with this least significant bit. So the 2's complement of 0011 will be 1101. So this is our answer. Now I have told you few minutes back that by using 8-bit you can represent 255 different numbers uniquely. But that was true for unsigned number. If you try to represent a binary number with sign, then you need to give 1 bit to represent the sign. Here this first bit or the most significant bit represent the sign. If it is 0, then the next 7 bit will represent a positive number, or if it is 1, then it will represent the negative number. Now if 1 bit reserved for sign, then how many distinct number you can represent by the next 7 bit? So for the sign bit, the formula will be 2 to the power number of bits minus 1, and then again minus 1. So by using 8-bit, we can represent 128 positive distinct number and 128 negative distinct numbers. Next question is how these numbers will be stored in memory. A positive number like 39 will be converted into binary sequence like 001, 00111, and then these binary numbers will be stored in memory. But for a negative number like minus 39, the picture is quite different. The binary sequence of 39 is not going to store in memory. It will first convert 39 into its binary sequence, and then it will calculate the 2's complement of 39, which is going to store in the memory. So this is how a negative number stores in memory. In the previous session, we have already completed the basics of binary number system, which is required to understand this bitwise operator. In this bitwise operator, we have 6 operators that are bitwise and, bitwise or, bitwise not, bitwise or, bitwise right shift, and bitwise left shift. So let's start with bitwise AND operator. Here we have table for AND operator. So note that we will get 1 as output if and only if all the operands are 1. Otherwise we will get 0. For example, we want to perform bitwise AND operator on 6 and 8. Now the operation will be performed on each bits. Here we have 0 and 0. So the answer will be 0 according to the table. And finally we will get 0 0 0 0 as the output, whose decimal equivalent is 0. So let me do it practically. So here I want to apply this bitwise AND operator on 6 and 8. So we need to write 6 and then we need to give the bitwise AND symbol and then we need to write 8. So now if I press enter, so note that it is showing 0. So our next bitwise operator is OR operator, and here we have the table for OR operator, and here note that we will get 0 as the output if and only if both the operands are 0. Otherwise we will get 1. For example, if you want to perform bitwise operator OR operator on 6 and 8, now the operation will be performed on each bits. Here we have 0 or 0, so the answer will be 0 according to the table. And then we have 1 or 0, so we will get 1. And ultimately we will get 1110. So if we write 6 or 8, then we will get 14 as the output. So this is the symbol for bitwise OR. Now let me do it. So it is showing 14. Our next bitwise operator is XOR operator, and here we have the table for XOR operator. So note that we will get 0 as the output if the operands are same. For example, it will give 0 if both the operands are 0 or both the operands are 1. For example, we want to perform bitwise operator on 6 and 8. Now the operation will be performed on each bits. Here we have 0s or 0, so the answer will be 0 according to the table. And finally we will get 1110 as the output, whose decimal equivalent is 14. So let me do it practically. So if I write 6, then XOR, then 8, so this is the symbol for bitwise XOR operator. And now if I press enter, we will find 14 as the output. Now our next operator is bitwise NOT operator or bitwise complement operator. Now this is a unary operator, which means this operator operates on one operand. For example, we have 6 and now I want to apply bitwise complement operator. So what will be the answer? First of all, it will convert the decimal number system into binary. Then it will flip all the bits. Now I have told you that the most significant bit is the sign bit and 1 represent negative binary number. So Python will find it as the negative number. And also I have told you that negative numbers is stored as 2's complement form in memory. So Python will think that next 7 bits are in 2's complement form. So it will return the number whose 2's complement is like this. Now we know how to find 2's complement, and exactly we need to do the same process to find the number from its 2's complement. So we need to first flip all the bits, then we need to add 1 and then convert it into its equivalent decimal number. And the most important thing is we need to add 1 minus sign, because here note that the most significant bit is 1, which represent that the next 7 bits are representing a negative number. So let me do it practically. So we need to write bitwise complement. So this is the symbol for bitwise complement operator. Then if I write 6, then we will get minus 7 like this. Now you need not to remember all these things, because if you have a question like this, then you need to simply add 1 with the number that is 6 here. So if I add 1, then we will get 6 plus 1, that is 7, and then add minus sign, and that will be our answer. For example, here we have bitwise complement 8, so just add 1 with this 8, which will be 9, and then also add minus sign. So our answer will be minus 9 like this. Our next bitwise operator is bitwise right shift. So here we have the number 6 and this is the binary representation of 6, and this line represent that right shift this binary representation of 6 by 2 bits. So what will be the answer? So first of all, last 2 bits will be deleted and 2 new empty blocks will be created at the left side. And then we need to fill these blocks with the sign bits. In our case, the sign bit is 0, so we need to fill these empty blocks with 0 like this way. And then calculate the decimal equivalent. In our case, it will be 1. So let me do it practically. So we need to write 6, then we need to give the bitwise right shift operator, and then we need to write 2. So the answer will be 1 like this. Our next bitwise operator is bitwise left shift operator. So here we have 6 and this is the binary representation of 6, and this line represents that left shift this number, that is 6, by 2 bits. So what will be the answer? So first of all, 2 blocks from left side will be deleted and 2 new blocks will be created at the right side like this. And then we need to fill these blocks with 0 and then calculate the equivalent binary number. So in this case, the answer will be 24. So let me do it practically. So let me write 6 and then bitwise left shift and then 2. So this is our answer. So this is the operator precedence. For example, if we have an expression like this, then here note that exponential operator has highest precedence. So Python will calculate first 4 to the power 2, that is 16. And then next powerful operator is multiplication. So Python will calculate 2 multiply 16, that is 32. Then it will perform the subtraction, that is 32 minus 1, which will give 31 as the output. You can also verify it. So this is the expression, and if I press enter, you will find that it will returns 31 as the answer like this. One more important point is, if we enclose something within parentheses, then Python is going to calculate that expression first. For example, if I enclose 2 minus 1 within parentheses like this, 2 multiplied by 4, then exponential operator, then if I enclose 2 minus 1 within parentheses, then Python is going to calculate this expression first. So it will give 1 and then it is going to calculate 4 to the power 1, that is 4, and then 2 multiplied by 4, that is 8. So in this case our answer will be 8 like this. We have already completed all the operators in Python. In this session we are going to learn input-output statement in Python. So let's start with input statement. If you want to take input from user, then you need to use the inbuilt function input, and then within parentheses you can pass the message. For example, if you want to take the age of a user, then you can pass enter your age. Now after seeing this message, user is going to enter the age. So we need to store this age in a variable. So let me declare a variable like age equals to, and then you can write this input enter your age, and then let me print the age like this. Your age is, and then we need to pass the variable that is age like this. And now if I run the code, so enter your age. So let me enter the age 28, and this is our output. Your age is 28. Now note some important point about this input function. In this case, user is going to enter a age, and age is an integer number. But if you print the type of age, then you will find it as the string value. For example, here we have age, and if I write print and then type of age, then you will find it as the string value like this. So here I am passing 28, and now note that this age is nothing but a string value, and this is true for all the values. For example, let me run this code. Okay, so here I am passing a float value like 40.5, then also it is going to take it as the string value. Not only that, if I pass a list, then also it is going to take it as a string value. For example, let me pass a list like this 1, 2, 3, then also it is going to take it as the string value like this. So the main point is, input function takes all the value as a string, but if you need to take the value as an integer or any other form, then what will be the solution? If you want to take this value in integer format or float format, then you need to use typecasting. So here we need to write int. If you want to take this value as an integer, then you need to use int, and then within parentheses you need to pass this whole total thing. Okay, and let me run this code. So if I pass 25, then it is going to take it as the integer value like this. Similarly, if you want to take it as a float value, then you can write here float, and then within parentheses you can pass this total thing, that is input, and then you can use this message. So let me run it. So here if I pass 20.5, then it is going to take it as the float. Now every time maintaining this type of input value is quite irritating. So instead of all this thing, you can use eval function in all the case. This function is more intelligent than other typecasting functions. If you pass an integer value, then this function will automatically convert it into integer type, or if you pass a float value, then it will convert it into float data type. And also if you pass a list, then also it will evaluate it into list. So let me do it practically. So if I pass eval instead of int or float anything like this, and now let me run this code. Okay, so let me pass a 20, that is an integer value. So note that it is showing it is an integer value. So let me run it again like this. So yeah, now let me pass a float value like 60.5. So note that it is showing a float data type. But note that here I am not using this float function. Instead of that, I am using eval function in all the case. So let me run it again, and now I'm going to pass a list like this 1, 2, 3, and then let me press enter. So note that it is showing list. Not only that, you can also pass a tuple like. So let me pass a tuple 1, 2, 3. So it is showing tuple. So eval is the intelligent function and you can use it in all the case. Now my question is, can you take inputs without using this inbuilt function, inbuilt input function or not? So the answer is yes. By using the concept of command line arguments, we can take inputs. But before jumping into that topic, let me explain something. Do you know we can run a Python file from CMD or command prompt also? So usually what we do is, we first create a new file like this, and then we save it. So let me first select the folder. So I'm going to save it in D drive like this, and there is source code and then Python codes. So here I'm going to store the Python file. So let me name it example.py and then save it, and then we can write the code like hello world. So like this way. So if you want to run this code in this ideally, then you need to click on run and then run module, or you can also press F5 from your keyboard and then press OK. So this is our output, but we can do the same thing in CMD also. To do that, we need to first open CMD like this, and now currently we are in C drive, but we need to go to the D drive because our Python file is saved in D drive. So here you need to write D and then colon. So now we are in D drive, and now we need to go to the location where our Python file is saved. So note that this is the location where our Python file is saved. So first of all we need to go to the source code and then Python codes. Okay, so here we need to write cd. Cd is the command to change directory. So first of all we need to go source code like this, source code. So now we are in source code, then we need to go to the Python codes. So let me write cd. So now we are in the location where our Python file is saved. Now to execute it, we need to write py, and then we need to pass the file name, that is example.py. So here note that this is our output, that is hello world. Now After let me just copy it. So after writing the file name, we can pass the inputs also. For example, if I pass 50, 60 and hello, so this is nothing but the command line arguments. Okay, this is the inputs. Now the question is how we can access these inputs in our program. After executing this line, a list with name argv will be created where we have all the inputs, but the first element of that list is nothing but the file name itself, that is example. But to use this list in our program, we need to import the sys module, and also we can access this element by using indexing concept. So let me do it practically. So to use the command line arguments, we need to first import the sys module like this, and then we can print the list. Okay, so let me first print the list. To do that, we need to write sys.argv, that is the list name. And also you can access the elements by indexing concept. For example, you can access the first element by writing sys.argv, and then within square bracket you can pass 0. So this is the first element, and similarly we can also access the other elements like this. So let me copy it. So this is the second element, this is the third element, and this is the fourth element. So now let me save it. Okay, and now coming to the command prompt. So let me execute this example.py with these values, with these input values that are 50, 60 and hello. So let me press enter. So here note that this is the list with name argv, that is like this. Example.py is the first element, then 50, 60 and hello, and note that all the elements are considered as string value. Okay, so this is our first value, this is our second value. You can also access these elements by this indexing concept like this. So this is all about input statements, and in our next video we will learn about output statements. In this session, we are going to learn about output statements in Python. In Python, if you want to output a message, then you need to use this inbuilt print function. So if I want to print hello world, then we need to write print, and then within parentheses you need to pass the message within inverted comma. So I am passing hello world. And now if you press enter, so it is showing the output, that is hello world. You can also pass multiple statements within this parenthesis. For example, here I have a string value that is hello, and then I have an integer value like 10. And now if I want to pass all these values within this print function, then we need to use comma. So we need to write a comma b, and also you can pass a message by separating them with a comma like hi. So if I press enter, so note that so it is showing all the value. So our next point is shape attribute. For example, here we have three integer value like a equals to 10, b equals to 20 and c equals to 30. And now if I print all this abc like this way, like print, and within parentheses if I pass a comma b comma c, then all these three values will be printed in one line like this. And here note that here we have space as the separator, or the default separator is space. But if you want to change this default separator, then we need to use this shape attribute. So what we need to do is we need to write print, and then within parentheses we need to pass a comma b comma c, and then we need to write the shape attribute like this way, and within quotation we need to pass the separator. So in this case I am passing colon. And now if I press enter, so here note that the default the separator is colon. Our next topic is end attribute. For example, if we have two print statement like print, and then within parentheses let me pass coding, and then we have another print statement, and here let me pass tactics. Okay, now let me run this code. So here note that after executing one line, one print statement, the control automatically comes to the next line, and then it is going to execute the next print statement like this. But if you want to print both these print statement in the same line, then you need to use this end attribute. So to do that, we need to write the end attribute in the first print statement like this, end, and then within inverted comma we need to pass a space so that it maintain one space, and then it is going to print this tactics. Okay, so now let me run this code. So this is our output. So our next topic is print statement with replacement operator. For example, here we have two variables that are username xyz and user age 30, and I want to print a message like hi xyz, your age is 30. To do that, we can write print, and within parentheses we can pass the message like this. But here I'm not going to use the name directly or age directly, but I'm going to use the variable name, that is username and user age. So let me do it. So instead of passing xyz, here I want to pass the username and then user age. So now let's see what will happen. So yeah, note that instead of fetching the actual name from this variable name username, it is showing the variable name itself, and here also it is showing the variable name, that is user age. So what will be the solution if I want to use the variable name instead of the name directly? So we have three methods to do it. So first one is we can break this in multiple statements. To do that, let me just copy it, and then you need to break it from here. So let me, okay, now this is a single statement, and then we need to pass the variable name as a separate statement like this, and then here start inverted comma and here end it like this, and then we need to pass this user age as a separate statement like this. So it is showing our expected output, that is hi xyz, your age is 30. But we can also use this replacement operator to do the same thing. To do that, we need to first write the print statement like this, and then instead of passing the variable name here, we need to open a curly bracket and then close it, and here also open a curly bracket and then close it, and at the end of the message write dot format, and within parentheses you need to pass the variable names that are username, and then we need to pass user age. Now if I press enter, so it is showing our expected output, that is hi xyz, your age is 30. And also we can do the same thing by using the f string concept. So to do that, we need to first copy and then here paste it. Now before writing this statement, we need to just write f, and then we need to pass the variable names within curly braces like this, and here also like this. And now let me print it. So here note that hi xyz, your age is 30. So this is our expected output. So this is all for this video. If you want to solve quiz related to programming languages, then you can join our Telegram channel, link is in the description. This is the continuation of my previous video where we started to learn the output statements in Python. So in our previous video, we have seen that to use the variable name instead of passing the actual value in a message, we can use the dot format method like this. But here one notable point is, in this message we want the username first. So in this parenthesis also we need to first the username, and then here we want the user age. So here we need to pass the user age, or in other words you can say that we need to maintain the order. But this is true if we don't pass anything within these curly brackets, or actually we can index these elements. For example, the index of the username will be 0, and then the index of the user age will be 1, and so on. So in this example, we have an integer value equals to 10, then we have a float value like 10.5, and then we have a string value that is hello. And I want to print this message in this order. So in this parenthesis, we need to pass these variable names accordingly, otherwise we will get an error. For example, here we need integer value first, so we need to pass the integer variable that is a. Otherwise we will get an error. For example, if I pass here the float value like b, and then if I pass the string then integer, so you will see we will get an unexpected output. For example, let me run this code. So here note that in the place of integer it is showing 10.5, which is a float value, and in place of float it is showing a string value. But you can, if you pass the index of these variables in these curly brackets, then it will print our expected output. So here we have passed the variables randomly. So here we want the integer value. So the index of the integer variable that is a is 2. So index of a is 0, 1, 2. So if I pass here 2, and then if I pass the index of float that is b, so the index of b is 0, and then if I pass 1 here, and if I run this code, so here it is showing our expected output. And you can also use some auxiliary name. So this is the next method. So let me pass here an auxiliary name that is I, and then if, and then s. And now within this parenthesis we need to pass this auxiliary name also. So here the auxiliary name of this b is nothing but the f. So here we need to pass f equals to b like this, and then s equals to c, and then I equals to a, like this way. And let me run this code. So here also it is showing our expected output. So this is how you can implement dot format method. Our next point is print statement with formatted string. But before going to that topic, we need to remember these points that are modulus I and modulus d represent an integer value, modulus f represent a float value, modulus s represent a string value. For example, here we have a integer value like a equals 10, and then I want to print this value, that is the value is equals to, and here I don't want to pass the integer value directly, but I want to pass here the variable name. Now in this case you can use f string and also dot format method, but here I want to use this formatted string. To do that, we need to write here the modulus I or modulus d, because here I want to represent integer value. So here I need to use modulus I, and then you need to write modulus and then the variable name that is a, like this. And if you print this, so this is showing our expected output. Now you may think, is there any advantage of using this formatted string or not? So there is an advantage, like you can typecast internally. For example, here we have an integer value that is a equals to 10, but you want this 10 as a float value, like that is 10.0. So to do that, you need to write here modulus f, and it automatically or internally typecast this a into a float value that is 10.0. Now let me print it. So here note that it is showing a float value that is 10.000. And also you can set this precision. For example, you want up to 2 decimal points like this. So you need to write here like, so here you need to write modulus then 0.2f. And now if I run this code, so here note that it is showing up to 2 decimal point like this. So our next topic is escape character. In Python, if you want to insert an illegal character in a string, then you need to use this escape character. Illegal in the sense, for example, here we have a print statement like Python is easy to learn. And now if I want to enclose this Python with a quotation, for example, if I use single quote, then it will be okay like this. And now if I run this code, so it is showing our expected output. But if I try to enclose it with double quote like this, then we will get an invalid syntax error like that. So let me run it. So it is showing invalid syntax. Now escape character comes into picture to save us. So escape character is nothing but a backslash followed by the character that you want to insert. For example, here I want to insert this double quote, so we need to use a backslash, then this double quote, and here also a backslash, then the double quote. Now if I run this code, so it is showing our expected output. Similarly, we have some other characters which have some other meaning if you add a backslash before it. For example, n is nothing but a character like print, and within quotation if I pass a, b, and like a and then n and then b, then it is going to print a and b like this. So it is showing a and b. And now if I add a backslash before n like this, then it is going to work as a new line. It means it first print a, then it is going to print b in separate line. So let me print it. So this is our output. Similarly, we have some other escape characters. You can try it. In our previous video, we have already learned about two attributes that are int and set, but we have another two attributes that are flush and file. So let's move ahead with the file attribute. So after writing the program, if you run it from here, that is from ideally, then the output will be shown in the Python shell. Or if you run the program from the CMD, then by default the output will be shown on the current shell, that is CMD. But if you want to print the output in any external file, then you need to use this file attribute. For example, I want to print the output in a txt file. So let me first open a notepad and let me save it. So here I'm name it as output.txt and save it. And now coming to the Python code. So here we need to first define a new shell like new shell, and then let me open it. So here we need to pass the file name, that is output.txt, and then open it in write mode like this. And don't confuse about these things because we will learn it in a very great detail in the file handling in Python. So just remember this thing, it is used to open the txt file only. And then let me print an output like print, and then here I'm writing hello world, and then let me define the attribute, that is file equals to new shell, this thing, and then let me close this file, that is new shell dot close. Okay, now if I run this code like this, so it is showing nothing. So where is our output? So actually our output is in the txt file. So this is our output, hello world. So this is how you can use this file attribute. So our last attribute is flush attribute. Flush can take only Boolean values that are false or true. And the default value of flush is false, which means the IO is in buffered mode. If it is true, then the IO will be in unbuffered mode. So what does it mean by buffered IO or unbuffered IO? For buffered IO, there is an internal buffer which is kept, and only when that buffer is full or it encountered with a new line, then the output will be flushed. With unbuffered IO, whenever a call is made to output, then it will do this one character at a time. Most IO functions fall into the buffered category mainly for performance reason. It is a lot faster to write a chunks of characters at a time. So let's understand this concept by an example. In this example, I want to print this line first, that is before delay, and then I have given some delay of 5 seconds, and then I want to print this line that is after delay. But here note that I have used this default value, that is flush equals to false. Actually, if you don't write it, then also the value of flush will remain false, and it means the IO is in buffered mode. So let me execute this code on CMD for better understanding. So let me open CMD and go to the desktop because I have saved the Python file in desktop, and then execute this file, that is temp.py. So it is showing before delay, and then after 5 seconds it is showing after delay. Actually it is showing the expected output because we know that after printing one line the control automatically comes to the next line, and the IO is in buffered mode, and it will release the output when it is full or it encounter with new line. So the problem will be occurred if I prevent the control to come to the next line by using the end attribute. So let me add here the end attribute, that is end, and then like this. And now let me save it and then execute it on CMD like this, and cd desktop and py temp.py. Now note the abnormal behavior. So it is not showing anything, but after 5 seconds it is showing both the statement at the same time. Actually this abnormal behavior occurred because I have prevented the control to comes to the next line after printing the first line. So here comes the unbuffered IO, that is flush with true to save us, because in case of unbuffered IO it will print one character at a time. So the behavior remains same. So let me do it. So flush, and let me change it to true like this, and now save it and then run it on CMD, then py temp.py, and now note the behavior. So it is showing the before delay, and after 5 seconds it is going to print after delay like this in the same line. Okay, because here I have used this int attribute, so it is showing in the same line. So this is how you can use this flush attribute. So this is all for this video. From this session, we are going to start a new topic, that is control flow statements. In this, we have basically three types of statements, that are conditional statements, where we have if, elif, and else keywords, and then we have iterative statements, where we are going to learn these two loops that are for and while, and then we have transfer statements, where we are going to learn break, pass, and continue. So let's start with conditional statements. We will learn this by an example. So assume that there is a job vacancy and there is only one eligibility criteria, that is your age should be within 20 to 40. Okay, so to do that we need to first take the input from the user. So to do that we need to write input, and then within parentheses you can pass the message, that is enter your age. Okay, now age is an integer number, so we need to typecast it into int. You can also use eval function, but I am using here the int function. And now we need to check the condition, that is if this age is greater than or equals to 20, and also it is less than or equals to 40 or not, and then we need to give colon like this. Now after giving the colon, press enter, and now here note that automatically Python skips some space, and don't rewrite it because this is for indentation purpose, and it basically denotes that this next line comes under this if block. So if this expression evaluates to true, then it will print it will print like you are eligible, like this. So we have done with our if block. So we need to break this indentation. And now write else and then write print you are not eligible. So first of all, after entering the age, the control will comes to the if block and it is going to evaluate this expression. If this expression evaluates to true, then it is going to print you are eligible, and if not, then control will comes to the else block and then it is going to print you are not eligible. So let me run this code. So it is showing enter your age. So let me give 30, which is within the range of 20 to 40. So our expected answer is you are eligible. So it is showing you are eligible. So let me again run this code. So now I'm giving it 50. So our expected answer is you are not eligible. So let me press enter. So it is showing our expected output, that is you are not eligible. Next we have nested if else statements. So let me take another example where the eligibility criteria is different. Like if you are a male candidate, then the eligibility criteria will be 20 to 40, and for a female candidate it is 20 to 30. So in this case we need to take the gender also. So gender equals to input, like pass the message like enter your gender. So we need to first check whether the candidate is male or female. To do that, we need to first write if and then gender equals to male. So we are checking for the male, and then within this if block I'm going to write another if block, that is the nested if, like if, and here I'm going to check the age criteria, that is age is less than or greater than or equals to 20, and also it is less than and equals to 40. And if this expression is evaluates to true, then it is going to print you are eligible. And if this expression evaluates to false, else it is going to print you are not eligible. So this is for male candidate. And if this expression is evaluates to false, then it is going to check for female candidate, like else if age is greater than and equals to 20 and less than and equals to 30, then it is going to print you are eligible, like this. If not, then it is going to print you are not eligible. So after taking these inputs, control comes to this outer if block, and then it is going to check whether this gender is male or not. If yes, then it comes to this nested if block or the inner if block, and then it is going to check this condition, that is whether this age within this 20 to 40 or not. If yes, then it is going to print you are eligible. If not, then it is going to print you are not eligible. But if this condition evaluates to false, then it is not going to check these conditions. Rather, it is comes the control will comes to the else block, and then it is going to check these age criteria for the female candidate. So if this expression evaluates to true, then it is going to print you are eligible. If not, then it is going to print you are not eligible. So now let me run this code. So it is showing enter your gender. So let me pass male and then age is 30, like this. So it is showing you are eligible because the first condition, that is if gender equals to male, is satisfied. That's why the control comes to this next if block, that is whether this age is within 20 to 40 or not. And here also the age criteria is also satisfied. So this is why it is showing you are eligible. So let me run this code again. And in this case also I'm passing gender is male and then age is 50. So here it is showing you are not eligible because the first criteria, that is gender equals to male, is satisfied, and that's why the control comes to the next if block, and here the age criteria is not satisfied because our age is greater than 40. So that's why it is printing this else block, that is you are not eligible. So let me run it again, and in this case let me pass female like this, and age is 25. So it is showing you are eligible because of first of all, after taking these inputs, this gender equals to male criteria will not be satisfied. So this is why it comes to the else part, and then it is going to check this condition, that is whether this age is less than 20 and greater than 30 or not. So in this case our age criteria will be satisfied, and that's why it is showing you are eligible. So this is how nested if else block works. And now we have another statement, that is if elif else statements, or you can say it as if else ladder statement. To understand it, let me take an example where you need to print the grade obtained by a student based on their input value. So let me first take the input value, that is number equals to input, and then within parentheses we need to pass enter the value, and then let me typecast it into integer. So this is our grading system, where if the number is less than 40 then the student will be failed, and if the number is between 40 to 49 then the grade will be C, or if the number is between 50 to 59 then the grade will be B, and ultimately if the number is greater than or equals to 60 then the grade will be A. So first of all we need to take the number from the student, and then we need to check for the first condition, that is if number is less than 40 or not. If it evaluates to true, then it is going to print you are failed. If this condition evaluates to true, then it is going to print you are failed. If not, then it is going to check for the next condition, that is elif, and here we need to write elif like this, and then it is going to check for the second condition. If it evaluates to true, then it is going to print your grade is C. If this condition also evaluates to false, then it is going to check for the next condition, that is elif, and whether this number is greater than or equals to 50 or less than and equals to 59 like this. Then it is going to print your grade is B. If this condition also evaluates to false, then it is going to check for the last condition, that is elif the number is greater than or equals to 60 or not. If yes, then it is going to print your grade is A. And finally, if any of these four conditions is not satisfied, then it is going to print else, the default case or the else part, that is enter a valid number. So actually here it is going to check whether this number is greater than or equals to 60 like this, and also it is going to check whether this number is less than or equals to 100 or not. If it evaluates to true, then it is going to print your grade is A. If not, then the control wheel comes to the else part, and then it is going to print please enter a valid number. Out of 100, if he or she entered 200 or 105 or 110, then it is going to print please enter a valid number. Okay, so let me run this code, and it is showing enter a value. So here I am passing 50, so it is showing your grade is B. And let me run it again, and here if I pass 30, then it is going to print you are failed. So in this session we are going to learn about iterative statements in Python. In this basically we have two types of loop, that are for loop and while loop. So whenever we need to execute a set of program repeatedly, then we need to use this loop concept. So let's start with for loop. For example, we need to print hello world 50 times. So we can write for I in range and within parentheses we need to pass 50 and then give colon. For now, forget about this thing and I will come back to this point. And now just keep in your mind that we need to print hello world 50 times, and under this for loop we need to pass our message, that is hello world. And now let me run this code. Okay, so this is our expected output. Now coming to the first point, that is what does it mean by range of 50. Range of 10 can be think of as a container which has 10 values that are from 0 to 9. And this is the default case. Like if you pass only 10 within this parenthesis, then it will start from 0 and it will end at 9. So it means a 10 is excluded. You can also verify it. So let me first typecast it into list and then let me print this function, that is range of 10. So here note that it is showing from 0 to 9. So here 10 is excluded. But if you want to store from 1 to 10, then you need to write range, and then within parentheses you need to first pass the starting value, that is 1, and then end value plus 1. So in this case our end value is 10. So here we need to pass 11, and then you can also mention the step value. So the default value of step is 1. So if you don't mention it, then also Python is going to take the step value as 1, which is the default one. And the step value 1 means it will store all the values from 1 to 10. But if you want to store the values from 1 to 10 by skipping one value, like you want to store 1 and then you want to skip 2, then you want to store 3 and so on, then you can pass here 2. So you can also verify it. So let me first typecast it into list and then you can pass the range and all these things and then press enter. So it is showing our expected output. So this is all about range function, and our next topic is what does it mean by in. Actually in is a membership operator. So here in this line we have I in range of 50, which means 0 to 49. It actually denotes that in each iteration I is going to store each value for that particular iteration. For example, at the very first iteration the value of I will be 0, and in the next iteration the value of I will be 1, and so on. You can also verify it by printing the value of I in each iteration. To do that, we need to pass here I instead of hello world. So let me pass I and then let me execute this program. So here note that this is the value of I in each iteration. In the first iteration, the value of I is 0, then 1, then 2, then 3, 4, 5, and so on. Now I think you have understood the concept of for loop with range function. Now we will discuss about the for loop with collection data type. So if you pass a collection data type like list, tuple, or any other collection data type, then I is going to store each element of the list in each iteration. And you can also verify it. For example, here we have a list like 10, 20, 30, 40. And now if I write for I in A, and then if I print the value of I, so in the very first iteration the value of I will be 10, and in the next iteration the value of I will be 20, and so on. So let me execute this code. So this is our output, like 10, 20, and 40. So let me discuss another scenario where we need to print the list by skipping one element. For example, here we have the list and we want to print 10, and then we want to skip 20, and then print 30, skip 40, then print 50. But if you write the code like this way, then it is not going to work, because actually if you pass the list name directly, then it is not going to work. Here we need to use the indexing concept. To do that, we need to first calculate the length of A. So here the answer will be 1, 2, 3, 4, 5. So the length of A is 5. And then we need to write for I in range of, and then within parentheses we need to first write the starting index, that is 0. Why? Because we need to print the value of the first element, that is 10. So here we need to pass 0, and then we need to pass the end index. So here the int index is nothing but 0, 1, 2, 3, 4. So here we need to pass 4 plus 1, that is 5, and 5 is nothing but the length of the list. So here we need to pass the list, that is the length of the list, that is b, and then define the step value as 2, because if you define it as 2, then it will automatically skip one element, and then give colon and just write print and then a and pass here I. So I works as the index of this list, that is a. And now let me execute this code. So it is showing our expected output 10, then 30, then 50. Next thing that I want to mention here is int attribute. If I want to print these values horizontally, then we need to use int attribute here, like int, and then specify a space within this quotation. And let me execute this code again. So this is our output. Our next concept is nested for loop. In this case, we have a loop which is going to iterate over another loop. For example, here we have a loop like for I in range of 1, 6, and then we have the inner loop or the nested loop for j in range of 1, 6, and then we have a print statement like this. And here note that this outer loop is going to execute for 5 times. Okay, and in the very first iteration the value of I will be 1, and with this value, that is I equals to 1, this inner for loop is going to execute for 5 times. It means this, with this value 1, it is going to execute for 5 times, and then the value of I will be changed to 2, and then with this value, that is I equals to 2, this inner for loop is going to execute for another 5 times. So let me print here I, and then let me give a int attribute like this. So let me run this code. So it is showing like this. Okay, let me change the line after each iteration of this outer for loop like this, and now let me print it. Okay, so note that with value I equals to 1, the inner for loop is going to execute for 5 times. Then with value I equals to 2, this inner for loop is going to execute another 5 times. So it means this outer for loop is going to execute for 5 times, but the inner for loop is going to execute for the 5 into 5, that is 25 times. Now we are going to learn about while loop in Python. In case of for loop, we have seen that we need to specify the number of iteration. For example, if you try to print hello world 10 times, then you need to write for I in range, and within parentheses we need to pass the number of iteration, that is 10, and then within this for loop we can write our statement, that is hello. And now if I run the code, so it is showing our expected output. But we can do the same thing by using while loop. To do that, we need to first write while, and then within parentheses we need to write the condition. But I will come back to this point, but for now just give colon, and within this while loop we need to write print and then pass the statement, that is hello. And now to define the condition, we need to first initialize a variable, an integer value, that is equals to 0, and then within this parenthesis we need to write a not equals to 10. It means this loop will execute this code until or unless the value of a will become 10. As soon as the value becomes 10, then our loop will be terminated. But here don't have any statement which will change the value of a or which will increase the value of a. So within this loop we need to write a plus equals to 1, which means after each iteration the value of a will be increased by 1. And now let me execute this code. So it is showing our output, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is our expected output. So here, as long as this condition remains true, while loop is going to execute this set of instructions that are present in this block. Now we have seen that we can do the same thing by using for loop and while loop. Then where is the difference? Actually, in case of for loop, we need to define the number of iteration. Like if you try to print any statement, then you need to give range of 10 or something like that. But what if we don't know the number of iteration in advance? Then it is better to use while loop. Let's take an example. So the problem statement is write a code where we need to convert a decimal number into its binary equivalent. The simplest way to get the binary equivalent of a decimal number is divide the number by 2 repeatedly until we get the quotient as 1. For example, here we have the number 50 and we need to divide it by 2. So we will get 25 as the quotient and 0 as the remainder. Then again divide it, then we will get 12 as the quotient and 1 as the remainder. Then repeatedly divided by 2 until we get our quotient as 1. So our binary output will be, or the binary equivalent of 50 will be 110010. And then again, if you try to find the binary representation of 75, then you will get like this. And now calculate that, or note that to get the binary equivalent of 50, we need to divide 50 by 2, 1, 2, 3, 4, 5 for 5 times. But for 75, we need to divide it by 2 for 1, 2, 3, 4, 5, 6 times. So the number of division is not fixed. Now in this case, we can use while loop. So first of all, we need to take the input from the user. So input, and within parentheses write your message, that is enter value, and then typecast that value into integer. And then you need to use while loop, and within while we need to repeatedly divide this a by 2. So first of all, we need to use modulus sign, because modulus sign gives us the remainder, and we will going to calculate the binary sequence from this remainder. So you need to write a modulus 2. So it will give us the remainder, and we need to store it in a temporary variable. Then let me append all this remainder in a list. So we need to first create a empty list like L equals to like this, and then let me store all the remainder in each iteration in this L list like L dot append B. And we are also interested to calculate the quotient, because here the condition will be based on this quotient. So we need to calculate the quotient like q equals to a divided by 2. And then we need to write a equals to q, because in the next iteration the dividend will be the previous quotient. So here we need to change a equals to q, and actually here we need to use float division, unless we will not going to get our expected output. And after termination of this while loop, we need to add the last quotient, that is 1, in our list, that is L dot append. Then here we need to pass q, or you can also directly pass 1, because in the last at the last iteration the value of q will be 1 always. Now we need to calculate the binary equivalent from bottom to up approach. So to do that, we need to first reverse the list like this, and then print the list. So if I pass 50, then our expected output will be 110010. So let me run this code. So here I am passing 50. So note that the answer is 110010, which is the expected one. That is, here also it is showing 110010. So let me run it again, and now I am passing 75. So it is showing 1001011. Here it is also 1001011. So this is how you can use while loop when you don't know the number of iteration in advance. So our next topic is infinite loop. For example, if I write while, and within this parenthesis if I pass true, or anything that is similar to true, then it will execute the code for infinite number of times. Like if I write hello, so let me run this code. So this is our output like this. So let me kill it. You can also pass here anything that is equivalent to true, like you can also pass a number like this, then also it will run for infinite number of time. Or you can also pass a non-empty list like this. Now let me execute this code. So it is showing like this. So our next topic is transfer statements in Python. In this we have three statements that are break, continue and pass. So let me move forward with break statement. It is basically used to break the loop. For example, here we have a list like this, and we have another empty list like b equals to like this, and we want to store first 5 elements from this list A to list B. So we can write for I in range, or for I in A, then let me append b dot append I, because I is going to store each of these variables for each iteration. Like for the first time it is going to store 1, and in the next iteration the value of I will be 2. So it is going to store that values in this list B. And then let me check whether the length of this list B is greater than or equals to 5 or not. If it is greater than or equals to 5, then we need to break the loop. And after that it is not going to continue with this loop, and it will break that loop and it comes out of this loop, and it will print, after breaking the loop it will print like this, break. So let me run this code, and then also let me print the value of B. Now execute this code. So note that in this list B we have these first 5 elements that are 1, 2, 3, 4, 5, and also after breaking this loop it is printing, it is showing break. So this is how you can use this break statement. So next we have continue statement. It is basically used to skip the current iteration. For example, we have a loop like for I in range of 1, 6, and now I want to print the value of I in each iteration. So I need to write print I, but I don't want to print the value of I when the I value is 3 or the I value is 5, like this. So here I need to write continue. So whenever the I value is 3 or 5, this continue statement will skip this current iteration, and it is not going to print the value of I, and it control will go to the next iteration. So let me execute this code. So this is our output 1, 2 and 4. This is how you can use this continue statement. Next we have pass statement. It is not going to do anything, or you can say it as the empty statement, or it is used when a statement is required syntactically but you don't want any command or code to execute. Let me take an example. So first of all we will take an integer number from user, and then I will first check whether the entered number is greater than 5 or not. If it is greater than 5, then we are not going to do anything, but if it is less than 5, then we are going to add 5 with that number. So let me first take the input, like input enter a value, and then typecast this value into integer format like this, and then check whether this entered number is greater than 5 or not. If it is greater than 5, then we don't want to do anything with this value, so just pass it, and then in else portion just add 5 with this value like this. a equals to a plus 5, and then print your entered value comma a. So let me execute this code. So first of all, I am going to enter 2, which is less than 5. So it will take this value and add this value with 5, and so it is showing 7. So let me again execute this code, and in this time I'm going to pass 10, which is greater than 5. So it is showing 10. It will not going to do anything with this value. So in our previous video, we have already learned about infinite loop concept. For example, if I write while and then within parentheses if I pass true or any value that is equivalent to true, then this loop will going to execute this print statement for infinite number of times. So let me execute this code. So it is showing like this. So in this video, I am going to make a calculator, and in this calculator, I am going to use this infinite loop concept in a better way. So let me first kill it, and then I'm going to take the operator from the user. So input, and within parentheses I'm going to pass enter your operator like this, and then within parentheses I'm going to pass the operators of addition, comma subtraction, comma division, comma multiplication, comma float division, and exponential. And in the next line I'm going to take the first operand, that is operand 1. So input, enter your operand or first operand like this, and then let me typecast it into integer format. So here I need to write int and then within parentheses like this, and then I'm going to take the second operand from the user like this. So operand 2, and this is second, and then simply just write if else statement for this each of this operand, like if operator equals to plus, then I need to return or print the answer is comma op1 plus op2, so like this. And for the next case, like let me copy it, then cb. So here I need to write elif operator equals to negative or minus, then we need to pass minus. Then again, so elif operator equals to division, then let me pass here also division like this, and then if it is multiplication, then here I need to print the multiplication. Let me elif, and then here also elif it is float division, then here also it will be float division like this. And for the and next we have the exponential. So in case of exponential, the operator 1 is nothing but the base, and operator 2 is the exponent. So here we need to write like this, and the default case or the last case, that is print, and then let me pass the message like enter a valid operator like this. So let me run this code. So here it is asking for operator. So let me just give a colon here like this, and now let me print it. So here it is asking for operator. So let me pass plus like this, and then enter your first operand. First operand is 5 and our next operand is 2. So this is our answer. So 7 is our answer. Now here note that after executing for one time, our calculator will be terminated. But here I am not going to terminate this calculator for after executing one time. Rather, I want to make it such a way so that user can decide whether he or she need to terminate this calculator or not. To do that, I'm going to use the infinite loop concept. So let me just cut it, and then here I'm writing while true. So while true, we'll going to execute this calculator program for infinite number of time. Okay, let me make the indentation. Okay, now it is fine. Now if I press enter to execute it, so it is asking for operator. So let me pass float division like this. So enter your first operand. Our first operand is 10 and our second operand is 2. So it is showing 5, and here note that calculator is not terminated, but it is showing for the next operation. I mean, it is ready for the next operation. But here note that we don't have any control to stop it. So to stop this infinite loop, we need to use a method that is exit, and this exit method is present in sys module. So we need to first import this sys module. So after executing each operation, like after executing addition or subtraction operation, it is going to ask for a value from the user, like b equals to input, and then within parentheses let me pass press press 0 to exit this infinite loop like this, and then let me typecast it into integer like this, and then based on the user value I'm going to take the decision, like if b equals to 0, then terminate the infinite loop. To do that, we need to use the exit method that is present in sys module, like sys.exit like this, and if he or she don't want to exit, then automatically for that also let me take a decision, like press 0 to exit or press 1 to continue, like this, continue. Okay, like this. And if the value is 1, the entered value is 1, then it is going to continue for the next operation, for next addition or subtraction, like that. So here also let me pass a value that is ready for next operation, like this. So now let me execute this code. So it is asking for operator. So I am passing plus, and our first operand is 5 and second operand is 6. So it is showing the answer is 11. So press 0 to exit or press 1 to continue. So if I press 1 like this, then it is going to ready for next operation, like this. So let me here also pass multiplication like this, then 5 and second operand is 7, so it is showing 35. And now I'm going to terminate this infinite loop. To do that, we need to press 0 and then enter. So now note that, so now we are out of this infinite loop, like this. So this is how we can use this infinite loop concept. So today's topic is function. We have already used function. Like you have already learned that if we have a list like this, and if I want to find the minimum number from this list, then we can write min, and within parentheses we need to pass the list, that is a. Now let me print this minimum number. So it will print -4 because -4 is the minimum number. So let me execute this code. So it is showing -4. Now here min is the inbuilt function and it helps us to find the minimum number from a list. Now the point is it reduces our work because to find the minimum number we need not to write the code from scratch. Or we can say that functions are very much useful and it runs only when we call that function. Like the code for min function is already written internally. Now the question is how we can use this function or how we can define a function from our own purpose. For example, we have to add all the values of a list multiple times in our program. So it is better to write a function instead of writing the code from scratch multiple times. Unless it will make our code lengthy. And also assume that we don't have the sum function. Actually, we have a sum function or we have an inbuilt function called sum. And if I write this function and then if we pass a in this parenthesis, then it will calculate the sum of the element of this list a. And now let me print it, and if I execute this code, so it is showing the sum of this element, that is 70. But for this moment forget about this sum function and keep it in your mind that we need to write this function from scratch and we don't have this function sum. Okay, first of all we need to write def. Actually def is a keyword which is used to define a function. Then we need to give a function name. You can give any name. Here I am giving my sum, like my sum, and then within parentheses we need to pass the value or the list on which we want to apply this function, but we don't know the list name, so here we need to pass a formal argument. You can pass any name in this parenthesis. In our case I am passing x, and now onwards you can use this x instead of actual list name, and we will pass the actual list while calling the function, and then give a colon like this, and within this function body we need to write the code which will calculate the sum from a list. Now we need to declare a variable like s equals to 0 to store the sum, and then let me run a for loop over this list x, like for I in x. Now in the each iteration I is going to store the each value of this list x. So for example we have a list like this, and in the first iteration the value of I will be 1, and then 5, then 3, like this. So in the each iteration let me add the value of I with the present value of s, like s equals to s plus I, like this. So in the first iteration the value of s will be 0 and the value of I will be 1, so 0 plus 1 will be 1, and in the next iteration the value of s will be 1 and the value of I will be 5, so it will add 1 plus 5, and now the value of s will be 6. So in the third iteration the value of s will be 6 and the value of I will be 3, so it will add 6 plus 3, that is 9, and in this way we can calculate the sum of these elements. And at the end of this iteration let me return the sum, that is s, like this. So this is our function, and to test this function we need to create a list. So let me copy it, and then a equals to this list, and now we are going to call this function, that is my sum, and then within parentheses we need to pass the list name on which we are going to implement this function. So here let me pass a, and then it will return the sum like this. So it will return a sum or a integer number, and we need to store it in another variable like b equals to this, and then let me print b, like print. So this is our function declaration, and then this is our function calling. Now let me execute this code. So it is showing our expected output, that is 70. So the sum of these numbers is 70. So the parameters that we pass at the time of function declaration are known as formal arguments. So in our case x is the formal argument, and the arguments that we pass at the time of function calling are known as actual arguments. So a is the actual argument. Our next topic is local variable. The variables that are declared within a function is known as local variables. The scope of this type of variables is within that particular function only. So let me declare a function def myFun, and here I'm not going to operate on any value, so here I'm not going to pass any argument. So let me just declare a local variable like a equals to 10. So a is the local variable, and then let me print the value of a, that is 10, like this. And then this is all about our function, and out of this function let me call this a. So a is a local variable, so it will works only within this function. When we call this function like my fun, and if I just let me just call it, and whenever we call this function like my fun, then only it will print the value of a, that is 10. But at the outside of this function, if I try to access this a, then it will raise an error because a is a local variable and it is not accessible from the outside of this function. So let me execute this code. So here note that when you call this function that is my fun, so it is printing the value of a, that is 10, because within this function a is accessible because a is a local variable of this function my fun. But outside of this function, if I try to access this value that is a equals to 10, then it is showing like name a is not defined. So this is the concept of local variable. Our next topic is global variable. Global variable means we can access it from inside of a function, and also we can access it from outside of a function. Like if I declare a equals to 10, then we can access this a from inside of any function, and also we can access it outside of any function. Like if we have a function like define my fun, and within this function I'm going to access this variable a like inside, and then let me print the value of a like this. And now we need to call this function, because unless we call it, it will not execute. And then I'm going to access this variable from outside of this function my fun, like print outside and now I want to print the value of a outside of this function. So let me execute this code. So it is fine, like inside within this function we can access this value of a, that is 10, and also in the outside we can access this value of a, that is 10. But here one problem is, if I declare a global variable and a local variable with same name, then the problem will occur. If we try to print the value of a local variable, then it will be fine. Like here we have a global variable, and inside this function I'm going to create a local variable with same name like a equals to 20. So a equals to 20 is a local variable and a equals to 10 is the global variable. And inside this function I want to print the value of local variable like local, and outside of this function I'm trying to print the value of global variable like global. So in this case it will works fine. Like if I print it, execute this code, so it is showing local variable that is 20 and it is showing the global variable that is 10. So in this case it is fine. But if I try to print the value of this global variable that is 10 inside this function, then also it will going to print the value of the local variable that is 20. Like if I write global, and now let me execute this code. Okay, so it is showing the local variable value that is 20 within this function. So what will be the solution if I try to access the global variable that is 10 within this function when the value of the name of the global and local variable is same? So in this case we need to use the global function. So first of all let me change it global to local. So in this function it will first print the value of the local variable that is equals to 20, and in the next line let me use globals function to print the value of the global variable. That is, we need to first write globals and within square bracket, and within this square bracket we need to pass the value of the name of the global variable that is a within quotation like this. And now it will return the value of the global variable that is equals to 10, and let me store it in x, and then let me print it like, let me copy it and pass here x, and it is global. So within this function it will first print the local variable that is equals to 10, and then it is going to print the global variable that is x, that is a equals to 10. And outside of this function we can only access the global variable, we can't access this local variable. So let me execute this code. So it is first printing the local variable that is 10, and then it is showing the global variable inside this function, and then outside of this function we can only access the global variable that is a equals to 10. So this is how we can access the value of the global variable inside this function when we have a local variable with the same name. Now my next question is, can we access this local variable outside of this function or not? Or what we can do whenever we need to access this local variable? To understand it, let's take a example. Like we are going to take the input from the user, like input, and within parentheses let me pass the message, enter your age, like this, print your age is, and also we are trying to access this local variable from outside of this function, like this. Let me remove it and let me run this code. So here note that within this function we can easily access this local variable that is your age is 20. So it is showing your age is 20. But outside of this function, whenever we try to access this age, that is a, it is showing error like name a is not defined. So what will be the solution if I try to access this age outside of this function? To do that, we need to first declare a as global variable, like by using this global keyword, like global and then a. So from now onwards a will behave like a global variable. So let me execute this code. So here note that it is showing your age is 28 within this myFun function, and also we can access this value of age outside of this function. So in our previous video we have discussed about functions in Python. Like to define a function we need to use this def keyword, and then we need to give the function name, in our case it is myFun, and then we pass the formal argument. In this video we are trying to understand how this formal argument and this actual argument that we pass while calling the function are linked with each other. So let's understand the execution of this program. So after executing this program, this line will execute first, because a function will not execute until we call it. So this block will not execute. So first of all, this a equals to 50 will execute. So object with value 50 will create in the memory like 50, and this name a will point to this memory location like this, and this object will have a memory address. So let's take 3000 as this address, and in the next line we are calling this function like myFun, and then we are passing the actual argument that is a. Actually we are passing the object reference that is 3000 in this function. So now onwards x also will point to this location that is 50, and you can also verify it by printing the id of this x inside this function, and also the id of this actual parameter that is a. So let's execute this program in ideally. So this is the program, and let me execute this code. Now here note that the formal argument that is x are pointing to this location, and this actual argument also pointing to the same location. So here x and a are pointing to the same location. Now my question is, what will happen if we change the value of this formal arguments inside this code, inside this function? Like if I change it from 50 to 100, so what will happen? So let me first print it like formal argument, and then I'm trying to print the value of x and then the location that is id of x. And here also let me print it after execution of this function. I'm trying to print the value of a here, and then I'm also trying to print the address like this. Let me execute this code first. Now here note that the formal argument, the value of the formal argument is 100 and it is pointing to this memory location, and the value of the actual argument remains same, that is 50, and it's pointing to the this memory location. And here note that these two locations are different, so as soon as we change the value of this formal argument in this function, then this both formal argument are and this actual argument are pointing to the different memory location with different value. So from this we can conclude that if we change the value of the formal argument inside this function, then it is going to point to the different memory location. And this is valid for all the immutable data types. Like if we have a float value like 50.50, or if we have a string value like string like this. So we can conclude that if we change the value of the formal argument, then it will not affect our actual argument, but it is applicable for the immutable data type. But what if we pass a mutable data type like a list? So let me pass here a list like 1, 2, 3, and then in this function I'm going to change the value of this list. Like I'm going to append one more value like x dot append 4. So now we will see what will happen. So let me execute this code. So here note that the formal argument is pointing to this memory location, and our actual argument is also pointing to the same memory location. And after changing the value of this formal argument inside this function from 1 to 3 to 1 to 3, 4, our actual argument has also changed from 1 to 3 to 1 to 3, 4. So we can conclude that if we pass a mutable data type like list or set, and then if we change the value of that list or set inside this function, then our original value or the actual parameter also change. So our next topic is different type of arguments. So here we have declared a function like def square of x. Here note that in this parenthesis we have passed one formal argument. So while calling the function, we need to pass that amount of actual argument. Like here we have passed one formal argument, so here we need to pass one actual argument. Like if I pass here x comma y, that is two formal argument, then here also we need to pass two formal argument like this. So if I pass here 5, and then it will return the square of 5, that is 25, and let me store it in a, and then I'm going to print it like this. So let me execute this code first. So it is showing 25. But here note that if I don't pass anything while calling this function, it will raise an error like this. Missing one required positional argument x. So it is mandatory to pass the same amount of actual argument that we pass while defining the function as formal argument. So if we pass two formal arguments, then while calling the function we need to pass here two actual argument, otherwise it will raise an error. So these arguments are known as required arguments. As far as the required arguments are concerned, these are the arguments which are required to be passed at the time of function calling, otherwise it will raise an error. So our next topic is default arguments. Python allows us to initialize the arguments at the time of function definition. Like here, if this function takes two formal arguments like x comma y, and then it will return x plus y. So if I pass here only 5, then it will raise an error, because here we have passed two formal arguments, so here also we need to pass two actual argument. But if I initialize this y with default value like 10, then it will not going to raise an error, because if I pass here 5 comma 6, then the value of y will be 6. But if I don't pass anything, then the value of y will be 10, that is the default one. So let me first pass here 5 comma 6, which will print 11. So let me execute this code. So it is showing 11. But if I don't pass anything while calling this function, if I pass only the value of x, then it is going to add this 5 with this default value, that is default value of y, that is 10, and it will print 15 like this. So this is all about default arguments. So our next type of arguments is variable length arguments. In a large project, sometimes we may not know the number of arguments to be passed in advance. In such cases, Python provides us the flexibility to offer the comma-separated values which are internally treated as tuple at the function call. By using the variable length arguments, we can pass any number of value. So to do that, we need to first give a star and then we need to give the tuple name. So because the elements that we pass while calling the function will be treated as a tuple internally. So let me give a name t, and then while calling the function we can pass any number of values like this, and then here I am trying to print the sum of all this element. So let me initialize s like this and then add all the values like s equals to s plus I and then return s. So let me execute this code. So it is showing 39 because the sum of these elements is 39. So our last type of arguments is keyword arguments. Python allows us to call the functions with the keyword arguments. This kind of function call will enable us to pass the arguments in the random order. Like here in this function, we need to pass two arguments. And I have considered the first argument as the integer value and the second argument as the string value. And now if I call the function with these values like first integer and then string, then it will works fine. Like if I execute this code, so here note that the integer value is 50 and the string value is string. But if I pass these arguments in reverse order like this, and then if I execute this code, so here note that in place of integer it is showing the string value. So in this type of cases we can use this keyword arguments. Like to pass an argument we need to use the keywords. Like here I have considered y as the string value, so here we need to write y equals to string, and then here I have considered x as the integer value, so here I need to pass x equals to 50, then it will work fine. Like this, the integer value is 50 and the string value is string. So our next topic is lambda function. Python lambda function is known as the anonymous function that is defined without a name. Python allows us not to declare the function in the standard manner, that is by using def keyword. Rather, the anonymous functions are declared by using the lambda keyword. So to declare a lambda function, we need to write lambda, and then it can take any number of arguments like x, y, z, and then we need to give colon, and then we can write only one expression like x plus y plus z. So it will return the sum of this x plus y plus z, and it will return the sum, so we need to store it in another variable like s equals to this, and then we can call this function by using s, like print the sum is comma then s, and within parentheses we can pass the numbers like 1 2 3 like this. Let me execute this code. So it is showing the sum is 6. So here note that we need to call this lambda function by passing the values like this way, like a's of 1 2 3. So our next concept is immediately invoked function expression. In this type, we need not to call this lambda function explicitly. Like if I write lambda and then x, y, z, and then x plus y plus z, in the same line we can pass the values like this way, and then let me print this total thing like print, and let me execute this code. So here note that it is showing 6. In this video we are going to learn about map, filter, reduce function, and also we will learn about list comprehension. So let's start with map function. To understand it, let me take an example where we have to return the square of the numbers from 1 to 10. So let me first define a function, that is def square, and this function will take one value x, and then it will return the square of that value, that is x multiplied by x, and then let me run a for loop like for I in range of 1 comma 11 like this, and then let me call this function square for each value of I, like square and then I, and here let me declare one empty list like this, and then let me append all these squares in this list L like this, and now let me print this list. So it is showing our expected output, but here note that we need 1 2 3 4 5 6 7 lines, so we need here 7 lines of code to implement this logic, but you can reduce this number of lines by using map function. So the map function in Python accepts a function and a list. It gives a new list which contains all modified items returned by the function for each item. Like, so if I use map function, then after writing this logic for this square function, we need to write map, and then within parentheses we need to first pass the function that is square like this, and then we need to pass the range or the sequence. Here we can pass any collection data type, but in our case we need to pass range 1 comma 11 like this, and then we need to typecast it into list like this, and then print this total thing like this. So let me run this code. So it is showing the same value. So here by using map function we can do all these things by using 3 lines of code only. So map function reduce your length of the code. Now we will learn about filter function. So to understand this filter function, let me take an example where we need to return all the even numbers that are present in the range of 1 to 10. So let me first define is even, and this function will take one value like this, and then it will check whether this value, that is x, is even or not, like x modulus 2 equals to 0, because if this expression evaluates to true, then the number, that is x, will be even. So if it is even, then just return that number like this, and if it is odd, then return O like this. And now let me run one for loop like for I in range of 1 comma 11, and then let me call this isEven function for each values of I, like isEven, and within parentheses we need to pass I like this, and then let me create one empty list L equals to like this, and now let me check whether this value of A is equals to not equals to O or not, because if this isEven function returns O, it means it is the current value of I is odd, so then we need not to append that number in this empty list. If it is not O, then only we are going to append this number in this list. So if A not equals to O, then just append it, L dot append A like this, and then let me print this list L. So if I run this code, so it is showing our expected output, because 2 4 6 8 10 are the even numbers that are present in this range 1 to 10. But here note that the number of line is 1 2 3 4 5 6 7 8 9 10 11. So here we need 11 lines of code, but you can reduce this thing by using this filter function. So after writing this isEven function, we need to use this filter function. So we need to write filter And then first of all we need to pass the function name, that is isEven, and then we need to pass the sequence, that is range of, in our case it is one range of 1 comma 11, like this. And then let me typecast it into list like this, and then print it. And also we don't need this else part. Let me execute this code. So it is showing our expected output. So the number of line is 1 2 3 4. So by using this filter function we can reduce the length of the code, which will increase the readability. Now we will learn about list comprehension. To understand it, let me take an example where we need to return the square of the numbers that are even in the range of 1 to 10. So to do that, we need to first define a function, define square, which will take one argument like this, and then it will return the square x into x. And let me define another function, that is isEven. This function is basically used to filter out the even numbers. It is also take argument like this, and then it will check if that number is even or not, like this. If it is even, then it will return that number. And then let me use filter function to filter out the isEven. So list, then filter, then it will take the isEven function and the range. Our range is, in our case the range is 1 to 10, so here we need to pass 1 to 11. So this is all about filtering part by using filter function. After that we need to use this map function. It will take the square function, and then it will take the filter out values, that is all the even numbers. And let me print b. So if I run this code, so this is our expected answer. But here note that we need 1 2 3 4 5 6 7 8. So here we need 8 lines of code to implement this logic. But we can do it by using 2 lines of code by using this list comprehension concept. So let me first define the syntax of list comprehension. So within square bracket we need to first pass the expression, and then we need to use the for loop, and then we can write our condition, and we can pass multiple conditions like condition 1, condition 2, and so on. So let me implement the logic by using list comprehension. So first of all we need to pass the expression. In our case the expression is square, because ultimately we are going to return the square. And then let me use the for loop for x in range of 1 comma 11 in our case, and then let me write the condition. So the condition is if x modulus 2 equals to 0, or if the value of if the x value is even, then only we want to do this operation, that is x into x. And then let me store this. It will return a list, and let me store it in a, and then print this a like this. If I run this code, so here note that this is our expected output. And you can, not only that, you can pass multiple conditions. So let me pass another condition, if this number is even and also it is divisible by 3 also, like x modulus 3 equals to 0. So now if I run this code, so this is showing our expected output, that is only 36. So our next point is, what is the difference between map function and filter function? So remember that we have used this square function while implementing this map function, and we have used this isEven function while implementing this filter function. So in this square function we are doing some modification, and in this after modification we are returning the modified value of that particular value. So, and in this isEven function we are doing some filtering based on some condition, and then we are returning the same function. So here is the difference. Actually, the map function performs a transformation on the each item, and then it will return the modified value. And in the case of filter function, it filters down the values, and then it will return that particular value. So it is not that if I pass ECBN function in this map function, while implementing this map function, if I pass ECBN function, it is not that it will raise an error, but it will not give the expected output. So let me write here ECBN. So if I run this code, okay, so here note that it is showing none, then 2, then none, then 2. So here in this ECBN function, it will return the number if the number is even. Otherwise, it will skip the number in case of filter function. But if I use this ECBN function in map while implementing this map function, then it will return the even number. This is okay. So here note that all the even number is there, like 2, 4, 6, 8, 10. But in case of odd number, it is not going to skip that number. Rather, it will return the none value. Okay, so this is the problem. So it is not showing any error, but it is also not showing our expected output, that is 2, 4, 6, 8, 10. So this is the difference. So in this session, our last function is reduce function. To understand it, let me take an example where you need to return the sum of the numbers from 1 to 5. So if I don't use this reduce function, then we can do it by using either some inbuilt sum function, or otherwise we can also do it by using for loop. So to do it, we need to write, first we need to define a number with 0, and then for I in range of 1, 6, and then for each value of I, let me add that value with a, like a plus I, and finally let me print a, like this. So it is showing our expected output. But if you don't want to use this for loop explicitly, then you can use this reduce function. So this reduce function is present in functool module. So we need to first import that module, like import functool, like this, and then let me define a function like add. It will take x and y, and then it will return the sum of x and y, like this. And then let me print functool dot reduce, and then it will take the function name, that is add, and then it will take the range, that is in our case it is 1, 6. So let me run this code. So it is showing our expected output. Actually the point is, this reduce function internally use the for loop, and the internal implementation of this reduce function is written in C programming language, so which is much faster than the for loop that we use in Python, like for I in range, like that. In this session, we are going to learn about recursion. Recursion is the most common programming concept. It means that a function calls itself. This has the benefit of meaning that you can loop through data to reach a result. But you should be very careful with the recursion, as it can be quite easy to slip into writing a function which never terminates, or one that uses excess amounts of memory or processor power. So in this video, we are going to learn about this recursion concept by using an example. So we are going to write a function which will return the factorial of a given number. So factorial of 3 means 3 multiplied by 2 multiplied by 1. Similarly, factorial of 10 means 10 multiplied by 9 multiplied by 8, and dot 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 up to 1. And two more things that you need to keep in your mind, that is factorial of 1 is 1, and factorial of 0 is also 1. So this is all about factorial. So this is our factorial function, and this function will take one value like this, and then it will return the factorial of that number. So in this function calling part, here note that we are calling this function with this value 3. So for that, this function factorial will be called for value 3. For now, just ignore this part and return and focus on this return statement. So in this return statement, here note that it is returning 3 and this factorial, and it is calling itself with this value 3 minus 1, that is 2. So for that, and again this factorial function will be called for value 2 like this, and here note that in the return statement it is again calling itself for 2 minus 1, that is factorial of 1. So for that, this factorial function will be called for this value 1. And now the question is, for how many times this factorial function will be called, because it should not be called for the infinite number of times. So there should be a termination condition. So this if x is greater than 0 is nothing but the termination condition, because at the each time it is going to check whether the value of x is greater than 0 or not. If it is greater than 0, then only it will return this statement, and again this factorial of 2 minus 1 will be called like this. So in this case the value of x is 1, and here it will going to check the condition, that is x is greater than 0 or not. So here it is greater than 0. So this return statement will be executed, and in this it will call factorial function for 1 minus 1, that is for value 0. So for that, in this in this step the value of x is 0, so this condition will not be satisfied. So it will go to the else part and it will return 1. It will return 1 to this function like 1, and then 1 into 1, like the value of this will be 1. So 1 multiplied by 1 is 1, so it will return 1 to this. So it will become 2 multiplied by 1, that is 2. So from this it will return 2 to this function, that is 3 multiplied by 2, that is 6. So this is how we will get our answer, that is 6. So this is the program. Let me execute this code. So it is showing our expected output, that is 6. So this in this line we are doing the recursion, and this is our termination condition. In this session, we are going to learn about file handling in Python. So we have created programs in Python that accept our input, manipulate it, and it will display the output. But that output is available only during the execution of that particular program, and input is to be entered through the keyboard. This is because the variables used in the program have a lifetime that is valid till the time of program is under execution. So what if we want to store the data that were input as well as the generated output permanently? So in this type of scenario, we can use file handling in Python. A file is basically a named location on a secondary storage. In Python, we can handle a text file as well as a binary file also. Binary file means your image or audio, etc. In this file handling, basically we can do the CRUD operation. CRUD means create a file, we can create a new file, we can read the data from that particular file, or we can update the data in that file, or also we can delete data. So these are the operations that we can perform by using this file handling concept. So let's do it practically. So first of all, we need to create a txt file. Although it is not a mandatory step, we can also create a new file by using some Python code, but we will see that later. But first of all, let me create a text file. So let me open first Notepad, and then let me put some text here like file handling in Python like this, and then let me save it, file, and save it. So I'm going to save it here in local disk D, and then file handling here. So let me save it here as example.txt. So after creating a txt file, the next step is to open that particular file. To open a file, we need to use this open function. Open is an inbuilt function. So and it will return a file object. So let me store it here, file, and then this parenthesis, within this parenthesis we need to pass the location where I have stored the txt file. So I have stored it in D drive. So D, then file handling, and then the text file name. And then we need to pass the mode, in which mode we want to open that particular file. I will discuss about it, but for now just let me pass here R. R stands for read. So this file will be opened in read only mode. So we can just only read that particular file. We can't write in that particular file. Then we need to write file dot read like this, and then let me just print the text that is there in the text file. So let me just print that data, and then after doing all the operations we need to close that particular file so that it frees up the memory that is occupied by that particular file. So let me just write file dot close. So if I run it, so here note that it is showing the text that is there in the text file, that is example.txt. So here open is the inbuilt function which is used to open a particular file, and this function will return a file object, and we need to store it in a variable, and then we need to use that file object to close that particular file. If I want to read the data from that particular file, so we need to use that object reference, that is file, and also we need to use the inbuilt method that is nothing but read. So this is how we can read the file. And also if you want to read the first 5 bytes or first 5 character from that particular file, then you can specify that number like 5. So if I write here 5, then it will just print the 5 characters from that file, first 5 character basically. So let me run this code. So here note that it is showing FILE, and then there is a space, so it is showing this total 5 character like this. So related to this read operation, we have another two methods, that are readline and another one is readlines. So let's start with readline. Readline method reads one complete line from a file where each line terminates with a new line. So for example, in our txt file we have text like this. So if I use readline, then it will read from here to here, that is from one line, one complete line. So let's do it practically. So here if I write readline, and within parentheses we need not to pass anything for now, and if I press enter, so here note that it is showing from lorem to this point. You can also check it in this, so it is showing this complete line. And next one is, you can also print some specific characters, like if you want to print first 2 character or first 5 character, then you need to pass this number within this parenthesis. Like if I write here 4, then it will print first 4 characters from the text like this. So here we have first 4 characters. Now to read entire file line by line using the readline method, we can use the loop. This process is known as looping or iterating over a file object. So first of all we need to use an infinite loop like while and then true, and within this loop we need to use this readline statement. So let me cut it, and if I paste it here, so now this line will print the first line of the text, but I don't want to print it directly. Rather I want to first store it in a variable like line, and then I want to print this variable that is line like this. Now you may think why I am doing like this. Actually while is an infinite loop, while true is an infinite loop. So there must be a termination condition, otherwise it will not work properly. So this is our text file, and first of all this readline method will return this first line and then the second line, and after returning this last line it is going to return an empty string, and based on that empty string we need to provide our termination condition. Like after printing this line, it is going to check whether this current line is empty string or not, like this. If it is empty string, then we need to break that loop. this infinite loop. So if I execute this code, so it is showing our expected output like this. Now if I don't write this termination condition, then this infinite loop will continue to print empty spaces like this. So this is all about readline method. Now we will see the working of readlines method. So readline methods read all the lines and return the lines along with the new line as a list of strings. For example, in our text file, so here this readlines method will take this first line as a string and this second line as another string, and then it will return all these strings in a list. So let me do it practically. So if I write, so let me remove all these things. So now if I write print, and within parentheses if I write file dot read lines, so let me execute this code. So here note that this is the list and our first string is the first line like this. This is our first string, and then this is our next line as a next string, so on. So this is how this readlines method works. Now if you want to print the first line of the text file, then you need to first store it in a variable like L, and because these readlines will return a list, and then you need to use the indexing concept to print the first line. That is, you need to write print and then L of 0, so it will print the first line. So let me run this code. So here note that it is showing the first line. So up to this we have already learned how to read data from a particular file, and also we have learned the different methods that are related to this read operation. And to read a file we have used this file mode, that is R. So it is basically used to open the file in read-only mode, and it will raise an error if the particular file is not present at the given location. So next we have read binary or RB. It will open a binary file in a read-only mode, and it will raise an error if the particular file is not present in that given location. So now let me use this RB mode practically. So first of all, here note that in this particular location in this file handling folder I have this picture, and now if I write here RB, and then here I need to pass this image, the name of the image, that is picture.jpg. Now if I write print and then file dot read like this, so now it is going to print. Now here don't think that it is going to print it is going to show the picture itself, rather it is going to print the binary stream or binary equivalent of that particular picture which is stored in your system to represent that picture. So let me first run this code, but before that let me close that file also, file dot close, and if I execute this code, here note that it is showing the binary file, that is the binary equivalent like this. So this is the binary equivalent of that particular picture that is stored in your memory to represent this picture. So our next file mode is R plus or plus R. It is basically used to open a file in both read and write mode. But before discussing this R plus or plus R, let me first discuss this W mode, or it is basically the write mode. It will open the file in write mode. If the file is already exist, then it will overwrite this previous content with the new content, with the new value. And if the file doesn't exist, then it will create a new file. We need not to create the file explicitly if it is not present or if it is not created in our system. So let's do it practically. First of all, we will see the case 1 where we have already a file that is like this, and I want to overwrite all this content with the new content by using this write mode. So in our Python program, let me here pass the file name that is already there in my system, that is example.txt, and let me open this file in write mode like this, and then I want to write, that is Python is easy to learn, like this. Then it will close the file. So if I execute this program, so it is showing 25 because we have 25 character in this. So now if I open the particular file, that is example.txt, so let me just close it. Now if I open this example.txt, so let me open example.txt. So here note that the previous content has overwritten with this new content, that is Python is easy to learn. So this is how we can use this write method. So write is a method which is used to write new content on a particular file. Now one more point about this write function is, if you want to overwrite the previous value with an integer value like this, and if you pass it like this 3, then it will raise an error like this. That is, write argument must be string, not int. So if you want to overwrite it with 3, then you need to pass here 3 as a string like this. And now if you execute this code, and now if you open your text file, so let me close it and open it again. So you note that here it is showing 3. So we have another method, that is write lines, which is related to this write operation, that is write lines. And write lines method, by using this write lines method, we can pass multiple string value, or you can say we can pass multiple lines. But we need to first store these multiple lines in a list like L equals to, and then we need to pass here my first line, and then we need to use \n, which is basically denotes to print the next string in next line. So then we have another string like second line, and here also \n, and then we have third line like this. And now within this write lines function, we need to pass the list name, that is L. And if I execute this code, and then if I open it, so let me first close it, and then if I open it again, so here note that it is showing our multiple string value, or you can say multiple lines. So now we have already done with this write mode. Now we will see the R+ mode. So if you open a file with this R+ mode, then you can also write some data in this particular file, and also you can read data from that particular file. So now we will perform a write operation by using this write lines function. So here note that initially we have my first line, second line, and third line. And in this program, let me add another string like this, that is fourth line like this. And now let me execute this code, and if I open the text file, so let me open this again. So here note that we have this new value. Not only that, you can also read data from that particular file. So let me erase all these things, and now if I write print and then file dot read, so it will print all the data like this, my first line, second line, third line, and fourth line. So this is how you can use this R+ mode. So we have done with this RB, then R+ mode, and also this write mode. And now we have this WB plus and plus WB, both are similar. So it is used to open the file in write mode. If the file already exists, all the contents will be overwritten. If the file doesn't exist, then the new file will be created. Now in this W mode or write mode, we have missed one thing, that is, if the file doesn't exist, then the new file will be created. So let's see this point. Now here note that in that particular folder we have only example. We don't have any text file named example1 or example2, something like that. And in our program I'm going to open a new file, that is example1, in write mode like this, and then I want to write here like new file is created like this. So we initially don't have anything within this folder with the name example1, but in this program I'm trying to write some data on example1.txt in that particular folder file handling. So now if I execute this code, so here note that it is showing 19. 19 is basically nothing but the length of this string. And now if I open this folder, so here note that a new file with name example1 has been created. And also if I open this file, so here note that it is showing new file is created. So this is the case 2. So we have already learned these things. And WB plus or P plus the plus WB is nothing but it will open the file in write mode. If it already exists, then all the contents will be overwritten. If not, then it will create a new file. And next thing we have A or A plus. A is basically used to open the file in append mode. If the file doesn't exist, then it will create a new file. Or A plus is basically used to open a file in append and read in both mode. If the file doesn't exist, then also it will create a new file. So let's see by an example. So first of all, let's see, if I open a file in write mode and then if I want to write something like initially in this file we have, so this is example, I'm trying to open the example1, this is this file. So initially we have new file is created, this value is there. And in our program, if I want to pass like more data, so if I want to pass here more data, and then if I run this code, and now let me open the example1 again like this. So here note that the initial data has been overwritten. So if I use write mode, then it will erase the previous data. But if I use append mode like this, then it is not going to erase the previous data, that is more data. So if I pass here more data, and then if I pass Python programming like this, then it is not going to overwrite the previous data, that is more data, and it is just going to add this new data at the end of the previous data. So let me execute this code. So if I open example1 again like this, so here note that it has added the new data, that is Python programming, at the end of the previous data. So in this video we are going to learn about modules in Python. In Python, modules are simply files with .py extension containing Python codes that can be imported inside another Python program. In simple terms, we can consider a module to be the same as a code library or a file that contains a set of functions that you want to include in your application. So in this video, I will create a module and also I will use it in my another program. So let me first create a module. So new file, and then save it as my module, like my module, and then I'm going to save it in D drive, and let me create a folder here, modules, and within this folder I'm going to save this Python file, that is mymodule.py. And so now let me define some mathematical function, that is define sum, and this function will take x comma y, and then it will return x plus y, like x plus y. And then we have defined subtraction like this, x minus x comma y, and then it will return x minus y, like this. And similarly we have defined multiplication, which will take x comma y, and then it will return x into y. So that's enough. So this is our module. So let me save it. And now I'm going to create my Python file where I'm going to import this my module. So let me create a new file. So save it in D drive like this, and this is my application.py. So the first step is we need to import that my module. To import it, we need to write import and then the file name, that is my module. And now I want to use the multiplication function. So here I want to print multiplication of 5 and 6. So here I need to write my module dot, and then we need to write the function name, that is mul, and here I need to pass x into the numbers, that is 5 comma 6, the actual parameters. And now if I run this code, so it is showing 30. Now if you import your module like this way, import my module, then you can able to use all the functions that are there in your my module, that is sum, sub or mul. Like you can also use the sum function, like print my module.sum 2 comma 6, then you will get 30 and 8, like this. Now if in your application if you need only this mul function, then also you can only import this mul function. To do that, we need to write import, like we need to write from my module import mul, but in that case you need not to use this module name, that is my module. So here you need to use only mul, only the function name. So now if I execute this code, so it is showing 30. Now the next point is you can also rename this function, like you can use from my module import mul as multiplication, and then here you need to use that alias name, that is multiplication. And now if I execute this code, so it is showing 30. But here note that if you import like this way, then you can't use other functions, that is you can't use the sum or sub function, then it will raise an error. And the next point is you can also check how many functions are there in your module. Like if I write import my module, and now I want to check how many functions are there in my module. To do that, we need to write dir, and then within parentheses we need to pass the module name, that is my module, and it will return all the functions that are there in the my module. So then print a, like this. So if I execute this code, here note that it is showing mul, sub and sum. In Python we have some inbuilt useful modules like math, sys and many more. So I will make a video on that on a separate video series. So this is all for this video.